Data is everywhere. And to properly deal with this data, we would need a language which would help us to access, modify, and update this data in a very smooth way. And that is where SQL comes in. So understanding the importance of SQL in mind, we have come up with this comprehensive course. So in this session, we'll start off by understanding the importance of database, what exactly is it, and then we'll understand the concepts of database management systems. Then we'll have a comprehensive introduction to SQL itself, and then we'll go ahead into the subsets of SQL. So we have DDL, DML, DCL, and TCL. So we'll understand what are these, and we'll also work with the commands which come under all of these subsets. Then going ahead, we'll work with the SQL functions. After which we'll work with different joins. So we have inner join, left join, outer join, and full join. So we'll understand all of these properly and we'll also implement them. Going ahead, we'll understand what is normalization in SQL and why is it important. And finally, we'll have a comprehensive lab session where we'll implement multiple queries to work with different data sets. So let's start off with the session. So let's start off by understanding what exactly is a database. Now, as it is stated over here, a database is a collection of information organized for easy access, management, and maintenance. Now, in this 21st century, we are surrounded with data. There is data which is being generated every single second, and this humongous amount of data comes from multiple sources and is present in multiple formats. Now, this is where the need for us arises to store this data in a proper format so that we can access it whenever we want. And this is where we would need the help of a database. So what a database does is it stores all of this data. So let's say if we have around 100 gigabytes of data or maybe even 100 terabytes of data. So this database stores all of this 100 terabytes of data at one single location. Now, when it stores the data, it makes sure that all of this data is properly organized. Now, let's say there are different tables or there's data related to different scenarios. So let's take one particular case. So let's say if it's data related to your company, now you would have multiple departments in your company. So you could have the technical department, you could have the support department, there could be HR, sales, marketing, and so on. So first what you do is you'd separate this data with respect to the department. Now, so in this entire database, you'll have one particular table maybe related to the technical department, there'd be one table related to the sales department, there'd be another table related to the marketing department, and so on. So what this does is, it helps you to organize your data in a better way so that whenever you want to read data or extract data from it at a later point of view, you can easily understand it. So storing data in a database is just one part. Now, the next part which comes over here is managing the data. So there is a lot of historical data present. So when it comes to a database, maybe you can store data which is even 10 years back, 20 years back, or even data which goes farther beyond that. Now, when you have data which goes back all of those years, it is very essential to manage this data properly. So what you'll do is, you will have these organized in a proper way so that whenever you want to extract the data with respect to one particular date, you can easily extract it. So all of these features, storing the data, accessing the data, retrieving the data, modifying the data, that is what a database provides you. Now, these are the multiple examples of a database. You could have a telephone directory, customer data, product inventory, and so on. So now that we've understood what exactly is a database, let's look at the type of data models. So what is a data model? Now, in simple terms, data model is a logical structure of a database. So the data models can be divided into two broad categories. So the first category would be object-based logical model and the second category would be record-based logical model. So when it comes to object-based logical model, you can consider this to be a blueprint for your database, right? So what you do in this is you set up a blueprint for the different entities which you have in your data. Now let's say if we take the same example of your company database, then in that database you would already have multiple departments, and apart from that you would maybe have a table related to all the employees, a table related to all the managers, a table related to maybe the salaries and so on. So what you do is you set up a blueprint of how each of these tables are related. So maybe let's say if you have one employee table and one department table. So what you do is you create a blueprint of how the employee table is related to this department table. So this gives you an overview of different entities in the table or different entities in the database, and also what is the exact relationship. So when it comes to the entity relationship model over here, you could have many different types of relationships. You could have one-to-one, many-to-one, one-to-many, and many-to-many, right? So simply put, when it comes to entity relationship model, you can consider this to be a blueprint of your database. And then we'll head on to the record-based logical model. So when it comes to record-based logical model, you can consider this to be the implementation of your ER model. So that is why it is known as record-based logical model. So in record-based logical models, as the name states, obviously you would have records. And this would give you a data model where it will tell you how these records are related to each other. So in this, the primary data model would be the relational data model. And most of our databases which we use regularly are the relational data models. So what happens in relational data model is our data is stored in a tabular format. So when I say a tabular format, the data is basically stored in the form of rows and columns. Now you can consider these to be two different things. So you can consider each column over here to be indicating a entity. So one column could be maybe the name of the employee, another column could be the salary of the employee, next could be the department of the employee. And each record would indicate one complete entry. So let's say if you have one record, now that one record would tell you the employee ID, the name of the employee, the salary of the employee, where does the employee stay, and so on. So this is what a relational data model gives you. Now, after relational model, we have something known as the hierarchical data model. So in the hierarchical data model, we have these records arranged in a tree-based structure. So what you can understand from this is, you can consider there is a root node at the top of everything. And from that root node, you have multiple nodes coming down. So I'll just repeat it again. What happens in a hierarchical data model is you have a root node and you have multiple nodes branching out of that root node. So you can take an example where, let's say, the top node is maybe the different courses a student can enroll for. That is your root node. And from that, you would have multiple nodes branching out. So there could be one node branching out or one record branching out, which would have the ID of the student, the name of the student, and maybe the course which the student has taken. So similarly, you have multiple of these records branching out from the root node. And then next to hierarchical model, we have the network data model. So the only difference between network data model and the hierarchical data model is, while the hierarchical data model is a tree-based structure, the network data model is a graph-based structure. So over here, you can have more than one parent nodes. So these are different types of data models which come under a database. So over here, we have the ER diagram. So ER diagram is basically the entity relationship diagram, and this gives us this blueprint over here. So as you see, this gives us the blueprint of the different jobs across different countries, across all of the employees, and across all of the departments. So now that we've understood the different types of models, let's understand what exactly is a DBMS, and let's understand some of its operations. So DBMS stands for Database Management System. Now we already have a database with us, but to work with a database, we would need a management system, right? Now the perfect example for this would be, let's say, our laptop or our computer. So we have a computer, but to work with a computer, we would need some sort of operating system to work with the computer, isn't it? So this is where we have operating systems such as Windows, Linux, and so on. So these operating systems help us to work with the computer or the laptop. Now similarly, whenever we have a database with us, to work with the database, we would need a database management system. And in this session, we'll be working with a relational database management system. So relational database management system, for this, the data model would be the relational model. Now these are different operations which you can do. You can add new files into the database. So let's say if you only have the employee table in your database and you'd also want to add the departments tables, you can go ahead and do that. Similarly, if you want to insert new data, now let's say there are 500 employees and in the next 1 year, you have made an assumption that there would be 500 more employees joining. So you'd have to insert data related to all of those employees as well. You can go ahead and retrieve all of the information related to all of the employees if you want to modify the data. So there would be cases where, let's say, the name of the employee is incorrect or the age is incorrect, or maybe there is some sort of mistake while we enter the data. We can go ahead and modify it. Similarly, we can, if we want, we can also go ahead and remove some data or remove the entire table or the entire file itself. Now let's understand the advantages of DBMS. So with the help of DBMS, we can share this data across multiple applications. Now, when you have a DBMS, you can integrate DBMS with multiple languages. Such as, let's say if you are building a Python program or a Python web application, and this Python web application needs to have a database at the backend. So what you can do is, the Python language itself would give you something, an API, or maybe it would have a syntax in itself to integrate it with the backend database. Right, so you can work with the database along with multiple applications. So this is what is known as sharing of data across multiple applications. And you also have enhanced security mechanism. Now when you're storing data, and that too lots of data, huge amounts of data, your primary concern needs to be to make sure that the data is secure at all points of time. And that is the major advantage of a DBMS. You can also go ahead and enforce integrity constraints. So integrity constraints are basically some constraints which you would want to give while inserting the data or modifying the data. Now, let's say there are some things which a normal employee cannot change. So let's say the salary of the employee. Now, if you have the entire employee table accessible to everyone in the company, so everyone can go ahead and change the salary values in that particular table. So what you do is you go ahead and set some constraints with respect to that particular column in the table so that nobody or only few people can go ahead and make those changes. Similarly, we have something known as better transaction support when it comes to DBMS. So the perfect example for this would be a banking system. And now there could be multiple cases where people are performing multiple transactions. So in banking system, we basically either withdraw money, deposit money, or we check balance. So when thousands of these transactions are occurring at the same point of time, there could be cases where some of these transactions occur at the same time, or maybe there is some sort of discrepancy between these transactions. That is why you have to make sure that either these transactions are completed perfectly, or if there is any sort of error, then the transaction can be rolled back. And we also have very good backup and recovery features. So let's say if some of the data gets corrupted or some of the data is lost, then there is very good backup mechanism for us to restore the data through the DBMS. So we've got all of this overview of DBMS. Now let's understand what is RDBMS. So DBMS stands for Database Management System, and as I've already told you, RDBMS stands for Relational Database Management System. So as it is stated over here, a relational database refers to a database that stores data in a structured format using rows and columns. And this is what we learned in a relational model. So whatever data we have, we store that data in the form of rows and columns. And this makes it easier to locate and access specific value within the database. Now let's say inside the entire employee table, I'd want to extract only those employees whose salary is maybe greater than $100,000, right? So these are very specific values. Now if the data is stored in rows and columns, it becomes very easy for me to extract all of those records. And this RDBMS is known as relational because the values within each table are related to each other. So let's say the name of the employee would be related to the employee ID. Similarly, the age of the employee would be related to the name of the employee. And the relation could exist among multiple tables as well. So there is a definite relationship between the employee table and the department table. So one employee can work in only one department at a time. It's not that there is one employee who is in the HR department and is also in the tech department. That is obviously not possible. So all of these are certain features of RDBMS. Now there are some more features. Let's understand all of them properly as well. So every piece of information is stored in the form of tables, which you've already learned. And these tables have something known as primary keys. Now these primary keys help you to uniquely identify each of the records in the table. So when you store data into a table, you need to understand that each record in the table is different. So if we take the same company database, now in that company database, if you have 500 employees, then you need to understand that each employee is unique. So let's say if there is someone known as Matt LeBlanc in your company, there can't be two Matt LeBlancs, right? So let's say if there are actually two Matt LeBlancs, then there need to be some sort of differences between these two Matt LeBlancs. So let's say if the first Matt LeBlanc, his age is 25, then the age of second Matt LeBlanc must be 30. But then again, let's say if the age is also same, then maybe the department in which these two work could be different. So maybe the first Matt could work in the HR department and the second Matt could work in the tech department, right? So with the help of primary keys, you can uniquely identify each row in your table. Now this is with respect to one particular table, and when you're linking one table to other tables, right? This is what we are talking about, the relational in terms of multiple tables. So in this case also there could be a lot of scenarios where there could be possibility of duplicacy. So this is where you use something known as foreign keys. And then if you have all of this data, let's say if you have a table with millions of rows and thousands of columns, then you'd have to retrieve information in a very quick way. So for this purpose, SQL provides you something known as indexes. And the best part of RDBMS is it gives you access privilege. So there are again a lot of scenarios where we have to ensure that only few people have access to certain parts of the database or certain parts of the table. This is where you can grant access to the user or revoke access to the user. Now let's go ahead and understand the difference between RDBMS and traditional approach. So the key difference is that RDBMS applications store data in a tabular form, which is what I've been saying from the starting of the session, whereas in the traditional approach, applications store data as normal files. So this could be a file with any format. It could be a file with maybe a .json format, .xml format, .pdf format, right? But when you want data to be in the form of an organized structure, that is where you'll go ahead and store all of this data in the form of a table, and then you'll store this in a DBMS. And it is stated that there can be, but there'll be no relation between the tables like in a RDBMS. So we are talking about the traditional approach. So in traditional approach, data is generally stored in either a hierarchical form or navigational form. That is, if there is a single data unit, it will have 0, 1 or more children nodes and 1 parent node. But you will not have any table structure over here when it comes to the traditional approach. So those were all of the basics of database and database management system. Now let's go ahead and understand what exactly is normalization. So normalization is very important when you're storing data in a database. So again, whenever you are storing data into a database, you are storing a lot of data, and there could be a lot of duplicate values, a lot of data which is redundant. So this is where you'd have to make sure that whenever you're inserting the data, all of this data is devoid of the redundancy. All of the data is atomic and there is no repetition in the values. And this is where normalization comes in. So as it is stated over here, normalization helps us to decompose larger and complex tables into simpler and smaller ones. So I'm just stating it again. So whenever you're storing data into a database, generally the raw data is extremely complex and it is and you can't really make sense out of it. So if you want a proper structure to the table, you will go ahead and use normalization and decompose that larger table into a smaller one. And now in normalization, you have multiple normal forms. So what you do is, to have that proper structure, you go through these different normal forms. So we'll understand those normal forms in this session. So we've got 1NF, 2NF, 3NF, and then we've got Boyce Codd normal form, 4NF and 5NF. So out of these, we'll comprehensively understand the first normal form, second normal form, and the third normal form. So again, let's understand the need for normalization. So whenever we are dealing with database, it's very essential to have a database with a good design. We can't have redundant data in our table. And also if we have redundant data, then to either retrieve the values or to maybe modify the values, the expense of the operations would be a lot. So to minimize that, we would have to use normalization. And again, to avoid any unnecessary replication of information, we will go ahead and use normalization. So this is an example to understand the concept of normalization. So we've got this table over here. And as you see, we've got these 4 columns. We've got student details, course details, prerequisite, and result details. Now, if you closely observe, you'd find some fault in this, or maybe you'll find that the structure is not really proper. So inside the student details, we have the student ID, name of the student, and date of birth of the student. Similarly, in course details, we have the course ID, course name, and maybe this is the duration of the course. And then we've got the prerequisite of it, and then result details. So this could be maybe the date of the exam, the marks scored by the scored in the exam, and the grade of the student. So if we take these individual columns, if we take this particular column, then we have to make sure that every column, so all of these columns, the attributes, those are unique, and also there are no multi-valued attributes. So as we see, there are multi-valued attributes over here. So we have name of the student, student ID, and date of birth in a single value. So this is not a proper table design. And again over here, we've got 3 things in the same column. Again over here, we've got 3 things in the same column. So whenever we have multi-valued attributes like this, we'd have to go ahead and divide them into single valued attributes. So now to understand all of that properly, we'd have to understand something known as functional dependency. So let's say there is this result over here, which would give us student, course, course name, marks, and grade. Now from this, as it is stated over here, student and course together defines exactly one value of marks. And student and course determines marks, or basically it means that marks is functionally dependent on student and course. And similarly, as marks is dependent on student and course, course name is also dependent on course, and grade is also dependent on marks. So what I'm trying to say is, when you have a table as complicated as this, you could have a lot of dependencies. So let's understand each of these dependencies properly. So we've got student, course, and marks. Now when you talk about these marks over here, these marks are obviously dependent on the subject or the course which the student takes, and the course in turn is dependent on the student. So the student, course, and marks are interdependent. This means that if you want the marks of the student, then you would have to know the student details as well as the course details. So this is the functional dependency which is occurring in this table. And similarly, we've got this functional dependency between the course name and the course. So this is the course name over here, and this is the course ID over here. So if we want to know what course is the student studying in, then we would obviously have to know the course ID. And similarly, if we'd have to know the grade of the student, then we'd have to know the marks secured by the student. So let's say if there is this grading system where if we grade somewhere between 80 to 100, so if the student gets somewhere between 80 to 100, then the grade is A. So this is the functional dependency I'm talking about. If we don't know the marks of the student, then obviously we won't be able to get the grade of the student. Now let's understand this in a better way. So as it is stated over here, we've got 2 attributes over here, P and Q. So in a relation, so the relation is stated by R, P and Q are attributes. So these 2 are the attributes. And attribute Q is functionally dependent on attribute P if each value of P determines exactly one value of Q. And to understand that, let's again go back to this. So this is our attribute Q and this is our attribute P. And if we want to get the value of this, we would obviously need to know this. So this is P, this is Q, and to get the grade A, we would obviously need to know that the student has scored 82 marks, and this is the functional dependency. And there are two types of functional dependency. We've got partial functional dependency and transitive dependency. So let's start with the partial functional dependency. So in partial functional dependency, attribute Q is partially dependent on attribute P if and only if it is dependent on the subset of attribute P. So here we have an example over here. So let's see, this is the report and we've got all of these factors. Now this is our attribute P and this is our attribute Q. So we can clearly see that marks of the student is partially functionally dependent on student and course. Similarly, course name is partially functionally dependent on the course. Now, to remove the redundancy in your table, you would have to make sure that there is no partial functional dependency. Similarly, we've got transitive dependency. This would mean that if Y is dependent on X and Z is dependent on Y, then this would mean that Z is also dependent on X. So this is the relation which we have over here. So if course is dependent on students and marks is dependent on course, then grade over here is obviously dependent on the student. So this is the transitive dependency which we'd have to remove from the table. And now we've finally come to normalization. So as it is stated, the three types of normal form which we're going to look today are the first normal form, second normal form and the third normal form. Let's start with the first normal form. So whatever table you have or whatever relation schema you have, it is in 1NF if and only if all the attributes in the relation are atomic. That is indivisible in value and there are no repeating elements or groups of elements. So this is our original table over here, student marks table, and we'd have to ensure two conditions. So the first condition is all attributes are atomic. So all of these attributes have to be atomic. That means that all of them have to be single valued attributes and not multi-valued attributes. And there should be no repeating elements or groups of elements. This would mean that all of these values should be unique. Now, when we take this and convert this into 1NF, we see that all of these multi-valued attributes have been taken or grouped into one single value. So over here from student details, we've got three separate columns. So this is taken as student ID, this is taken as student name, and this is taken as date of birth over here. Similarly over here from this is taken as course ID, course name, and over here we've got the prerequisite. And we've got from this the result over here. So from the result we can get the marks, grade, and the date of the exam. So this is how we have made sure that all of the data in this table is single valued and it is unique. So now we have converted the table into 1NF, we'd have to proceed it to the higher level, which is 2NF. So to ensure the table is in 2NF, we'd have to make sure that the table is in 1NF first. And after the table is in 1NF, we'd also have to ensure that there is no partial dependency between non-key attributes and key attributes. So you would not know what a non-key attribute is and a key attribute is. So let's understand this properly over here. So these values which you see over here, student and course. So these are the key attributes. Now what are key attributes? A key attribute helps you to uniquely identify a record which you were talking about. So let's say if you have the same company database and if you have different employees, if you have 500 employees, then to uniquely identify each employee, you would need to have the employee ID. So each employee would have a unique employee ID and that way we can easily identify him. So over here we've got student, which is the key attribute. Similarly, we've got course, which is the key attribute. And apart from this, all of these would be non-key attributes. So we'd have to ensure that there is no partial dependency between these two. So what this means is, now the student table has to be separate, the course table has to be separate, and the exam table has to be separate. We have clubbed everything into a single one over here. So as it is stated, to get the second NF or 2NF from 1NF, we'd have to take three separate tables. So the First table would be the student table, second would be the course table, third would be the duration days and date of exam. So we'll take student name and date of birth into the student table, course name and prerequisite into the course table, and the rest would be the result table. So over here we have got the 2NF from 1NF. So in 1NF all of these columns were clubbed into one single table. Now to get into 2NF we had to make sure that there is no partial dependency between key attributes and non-key attributes. So over here we had a dependency between student and course. Similarly we had a dependency between course and the result, which shouldn't be the case in 2NF. So that is why we have separated out the student table, separated out the course table, and also separated out the result table. So this is also done. Now after this is done, we would have to head to the third stage, which is 3NF. So for the table to be in 3NF, the first condition is the table should already be in 2NF. Now, after we make sure that the table is in 2NF, we'd have to make sure that there is no transitive dependency between non-key attributes and key attributes. So if we take a look at the result table over here, so we see that course is dependent on student, marks is dependent on course, and grade is dependent on course. But this shouldn't happen. So this is the transitive dependency which we see. So grade over here should only be dependent on marks and shouldn't be dependent on the student. So what we'll do is we'll separate out marks and grade and we'll create a new table out of this. So in the result table we'll only have student, course and marks, and in the grade table we'll have marks and grade. So this is how we can convert a 2NF table into a 3NF table. Now let's start off with an introduction to SQL. Now you would have worked with a lot of programming languages, let's say C, C++ and Java. But the problem is these languages would not explicitly help you to work with a database. So this is where the need arises to have a specific programming language which would help you to work with a database. And this is where SQL comes in. So SQL basically stands for Structured Query Language. So you have different queries which would help you to create a database, manipulate a database, and share or access data from that database. Now understand, let's three of these aspects properly. Now when we say creating a database, it's very important. This basically becomes the primary part of SQL because you have to store the data somewhere. Let's say you would have an employee table or a student table or maybe a table with respect to all of the patients in a hospital, and you would have to store all of this data somewhere. So what you do is you go ahead and create a database, and in that database you can store multiple tables. Now the important thing to consider over here is you need to understand that a database is something which provides a proper structure to all of your data. So let's consider the college database. Now let's say if you want to store all of the data related to some particular college. So what you can do is you can create a database named as college, and in that you can have a separate table for all of the students, a separate table for all of the teachers, and maybe a separate table for the grades or the different departments in the college. So this is the creating part of the database. You can create a database and you can also create multiple tables in that database. So the primary thing to note over here is all of the tables which you store inside a database have to be similar. So this is the need of a database, of creating a database. Now, once you create a database, you can go ahead and manipulate the data which is present in the database. And this is the primary reason why SQL is so widely used. Now, let's say you have that student table in that college database. Now you would want to know all of the top scoring students, or maybe you would want to know all of the students who failed in a particular subject. So all of this you can find out with just maybe one line of query or two lines of queries. So that is how SQL makes your task extremely easy. And also whatever data you store in your database, you can make sure that only some specific people have access to that particular data. So this is where the share and access part comes in. So you can ensure that only people who are important or only people, the right people, can have access to that data, and it is shared among those people who actually understand that data, and this doesn't go out of the primary group. Right? So this is the importance of SQL. So now let's understand, why do we need SQL? So SQL is widely popular, which we've already understood. Now let's look at some of the advantages of it. As it is stated over here, SQL allows users to communicate, that is access and manipulate the database, which we've already understood. Now SQL is the primary language to access a database. Now you would say that we can also connect with the database with maybe Python or C, but what you fail to understand over here is maybe when you connect your programming language to a database, let's say if it's Python or Java, but to manipulate the data or to access the data, you are writing SQL queries in Python, or maybe you're writing SQL queries in Java. So SQL is the only language which would help you to access and manipulate the database at the backend. And that is why even if you know all of the high-end languages, SQL is very, very important when you'd have to deal with any sort of data. And SQL, as it is stated over here, it would also help you to retrieve data from a database. So storing is one aspect of it, retrieving is the second aspect of it. Obviously, when you store a data somewhere, you would want to retrieve it and would want to have a glance at it, wouldn't you? Right? So storing and retrieving is done, and you would also want to update, modify or delete whatever data is present over there. Now, time to time, there would be a lot of changes in the data. So let's say if we take the student table in that college database, that be new students joining, or maybe let's say there's some corrections in the grades of the students or the marks of the students. So all of this has to be updated. There are a lot of cases where there could be a slight error in the names of the columns. So all of that can be modified, and you can also go ahead and delete some specific rows, or maybe you can go ahead and delete an entire table. So let's say if you've lost some records, or maybe there's some discrepancy in the data, then you can go ahead and either modify the data or delete that data. So all in all, SQL is basically a language which would help you to define the structure of a database, and it is not just limited to that. Once you define the structure of a database, you can go ahead and create and access data in it, you can retrieve data from it, and you can also modify and data whichever is present in it. So all of these are advantages of SQL. So now that we've understood what exactly is SQL and why is SQL so important, let's look at some specific terms which are related to SQL. So the first term, the primary term which is so important in SQL is data. Now, my question to you guys is, what exactly is data? So think for a while. Now, what comes to your mind when you hear the word data? So in simple terms, data is just facts and figures, as simple as that. Now, let's say when you work with numbers such as 30, 500, 1000, all of these numbers are nothing but data. When you work with sentences or characters, let's say if you have a sentence such as my name is pizza, or I like pizza, or I'm going to Paris this Sunday, all of these are statements which again is data. Now when you work with mathematical formulas such as a plus b whole square is a square plus b square plus 2ab, what is that? That again is data. And when you talk about computers in general, data for computers would be binary code, zeros and ones. So in simple terms, whatever facts you deal with, that is data. Now, when you have all of this data with you, you'd have to store it somewhere, right? And that is where a data comes in. So to sum it up, data is basically defined as facts or figures or information that is stored in or used by a computer. So in simple terms, whatever facts you have, whatever raw data you have, you can go ahead and store it in a computer, and that is known as data. And now, when you have all of this data, it becomes very, very important to organize it in a proper way so that you can retrieve all of this information whenever you want it. And that is where a database comes in. So as it is stated over here, a database is an organized collection of data or information so that it can be easily accessed, managed or updated. Now, let's take the same example of the college database. So you would have a lot of data with respect to that college. As I've told you, there could be data related to students, there could be data related to teachers, there could be data related to the different departments of the college. Now, all of this data is present in a haphazard manner, and if you just store it in a random way, then retrieving it and finding information out of that raw data would be very difficult. So what you do is you go ahead and collect this data and provide some proper structure to it, and then go ahead and store it in a database. Now let's say if you have all of that data, so what you do is first you find out whatever data is only relevant to students. You take that data and create a student table out of it, and then go ahead and store the student table inside that college database. Now similarly, you will find out whatever data is relevant to all of the teachers. You will take this data and store it in the college database. Similarly, you will find out whatever data is similar with respect to different departments. Let's say if it is an engineering college, then you will find out the data with respect to different departments, such as you would have a computer science department, you would have a mechanical engineering department, you would have a chemical engineering department. So you will have specific data with respect to all of these different departments, and you will store it in one particular table, and then take all of these tables and store it in a database. Now, once all of this data has a proper structure in the database, you can go ahead and use SQL and maybe modify the data or retrieve the data. So those are the basic terms in SQL. Now let's look at the different data types which we can work with in SQL. So first we have numeric data. So as I've told you, when you work with numbers, all of that is numeric. So these are different types of numeric data you can work with. You've got bit, tiny int, small int, and so on. So this is the different sizes of the data that you can store. It basically increases in size over here as you go from bit to big int over here. Now it's just that you can store a number of a greater value in big int when you compare it with just a bit. Now all of these would be integer values, and if you want to store decimal values, you have over here. So you can store decimal values in either decimal or float. So these are the different types of numeric data you can store in SQL. Similarly, you can store character or string data. A character would be, let's say, all of the alphabets. You got A, B, C, D, E, F, G, H, all of these characters. And similarly, you have varchar over here. Varchar stands for variable length character. So in variable length character, you can store different strings. Maybe you can store a string called as pizza. You can store a string called as Sparta. So whatever it is, you can even store sentences. So I love Sparta, or maybe I love pizza. So whatever these sentences are, you can just go ahead and store it in varchar. And then we have a data type called as date time. Now there would be a lot of cases, especially when you're dealing with data, that you'd have to store data with respect to date or time. Now all of this would be historical data, and it would be very important to know what exactly is the date with respect to all of this. So again, if we take the same college database, then we'd want to know on which date which exam had occurred. So something like this. So let's say if it's an engineering college, then we'd want to know on which day the computer science exam was conducted. Similarly, on which day the chemical engineering exam was conducted. So date time is very, very important. So we have all of these over here. We've got the date data type, and with this, you can basically store the date, which would have your year, month, and then day. And then you have the time over here. So with the help of time, you can store hours, minutes, and seconds. Then you have date, time, which helps you to store date and time at the same place. Now, similarly, you have year. You can store the year at which some sort of event would have occurred. Now, after this, we have Unicode or character strings such as nchar, nvarchar, and ntext. And after that, we also have miscellaneous data types. Now, there would be a lot of cases where we'd want to store some sort of XML data or JSON data. Then SQL also provides us an opportunity to store XML data and as well as JSON data. So those are all the different data types which we could work with in SQL. Now, let's understand what exactly are constraints in SQL and look at the different types of constraints. Now, when it comes to SQL, there'd be a lot of scenarios where we'd want to restrict some type of data which we are storing into the table, or restrict some type of data which we are extracting from the table. So this is where we need constraints. So constraints, as the name states, would put in some sort of constraint on the table when you're either storing the data or retrieving the data or maybe even modifying the data. So the first constraint which we have over here is the not null constraint. Now, let's say if we have 5 columns in a table, and the first column in a table is the employee ID. Now, you want to make sure that no row in this employee ID column is left as a null or is left as an empty value. So this is where we'll put a not null constraint. So the not null constraint ensures that the user provides some sort of input with respect to this particular column, and if the user does not provide an input, then SQL would arise an error. So as it is stated over here, not null constraint ensures that a column does not have a null value. After that, we have the default constraint. Now, many a times it would happen that we would want to store a default value for a particular column. So here, let's say, as it is stated over here, provides a default value for a column when none is specified. Let's say we have the age column in the student database, and we are dealing with maybe the 12th standard students. Now 12th standard students, their age would be 17 or 18 in general. So what we do it, by default we'll set all of the students age to be 18 because it is easier that way, and there will be very few cases where the age of the student is not 18. So wherever the age of the student is not 18, then we can go ahead and modify it later on. So wherever if we want to set a default value with respect to a particular column, we can use the default constraint and set a default value over there. After that, we've got this unique constraint over here, which ensures that all the values in a column are different. Now, let's say if it is again the employee ID or maybe the student ID, then it is absolutely necessary that every employee should have a unique employee ID, or every student should have a unique student ID. And to these columns, you would put in this unique constraint, which would ensure that whatever data is fed into the employee ID column or the student ID column, you are making sure that that data inserted is totally unique. And after that, we've got this primary constraint over here. So this primary key or foreign key constraint ensures that each row or record in a database is uniquely identified. Now, what does this mean? So simply put, you can consider the primary key constraint to be a combination of your not null constraint and the unique key constraint. So when you add the primary key constraint to a particular column, you are making sure that whatever value is inserted, it is not null. That means that you definitely have to insert a value, and the value which you are inserting, it has to be unique. And this helps the table to uniquely identify each row or record in that particular database. And after the primary key, we have the check constraint, which ensures that all of the values in a column satisfy certain conditions. Now, there could be a lot of cases where you'd want to specify one particular check, which would ensure that there is proper retrieval of data or proper storage of data. That is why you can use the check constraint. And then we finally have the index constraint, which helps us to create and retrieve data from the database very quickly. So we've got different indexes such as clustered indexes and non-clustered indexes, and with the help of these different indexes, we can make sure that the data retrieval is very easy and it's very fast. So those were the different constraints in SQL. Now let's go ahead and look at the different subsets of SQL. So these are the different subsets in SQL. We've got DDL, which stands for data definition language. Then we've got DML, which stands for data manipulation language. After that, we've got DCL, which stands for data control language. Going ahead, we've got TCL, which stands for transaction control language. So we'll work with all of these, and first we'll start with the data definition language. That is stated over here. Data definition language is a primary mode of SQL queries where we are able to create objects for the database. So let's understand this database. So let's understand this data definition language in a more comprehensive way. So this data definition language comprises of all of these commands. So we've got the create command in DDL, which would help us to create objects in a database. So with the help of this, you can either create a database or create a table with SQL. And then you've got the alter command over here. So alter command is used to alter the structure of a database or database objects. Now, this would mean that wherever, let's say, you would want to change a particular row value or maybe change a particular column value, that is when you can use this alter command. Then you got the drop command, and drop command helps you to delete all the objects from a database. So let's say you have that same student table in your college database, and for some reason you would want to go ahead and delete that student table. So what you'll do is you'll use the drop command and you will remove that student table from your college database. Now, similar to the drop command, we also have the truncate command, which would help us to remove all of the records from a table permanently. Now, you need to understand the difference between a drop command and a truncate command. So when it comes to the drop command, you are deleting all of the values present in the table and you are also removing the table itself. But when it comes to the truncate command over here, you are only removing all of the data which is present in the table, but keeping the table intact. The table or the structure of the table remains as it is, but the data which is present inside the table is deleted. After that, we've got this rename command over here, which would help us to rename a particular table or maybe rename a particular column in the database. So these are the different commands which come under DDL. Now let's go ahead and perform our first SQL query, for which all of you guys have been waiting for. So our first task would be to create this employees table over here, and to create a table the syntax would be this. So we'll use the keyword create and then we'll follow it up with the table command. After that, we'll give in the name of the table over here. So here we'll type in create table and the name of the table is employees. And we'll have this parenthesis over here, and inside this we'll give in the name of the column, and after that we will give in the data type of the column. So first we want the employee ID column, and this is of integer type, and the size or the length of the employee ID is 10. And after that we also have this not null constraint, which would ensure that we don't have any nulls in this particular column. Going ahead, we have the next column, which is first name over here, and the data type of this is varchar, and this is variable length characters. So we have a variable length size of 20 characters. After that, we have the last name column over here. Again, the data type is varchar, and we are setting the size to be equal to 20, and we are ensuring that all of the values are not null. And finally, we have the salary column, which again is of integer type, and this also is not null. So over here, apart from first name, we are ensuring that the rest of the columns, they have some sort of value inserted into them. And then finally, we are ensuring that this employee ID column, all of the records in this employee ID column are uniquely identified in the table with the help of this primary key command. So we're using primary key, and inside primary key, we are passing in this employee ID column. So let's go ahead and create our first table in MySQL. So guys, this is how MySQL Workbench looks like. Now I will go ahead and write down the command over here. So it will be create table, and after this I'll have to give in the name of the table. Now I'll give in the name of the table as employees, and I'll give in space over here, and after this I'd have to give in the name of the first column. So name of the first column would be, let's say, employee ID, and this is of integer type, and the size is, let's say, 10. Now after this I would have to give in a constraint which is not null. So I'm ensuring that a value is inserted in the employee ID column. So I'd have to put in a comma after this, and after this I have the first name column. So I will have first name over here, and this is of varchar type, and I am setting a length of 20 for this. And after this I'll give in the next column, and the name of the next column would be last name, and I'll also set the varchar over here. I'll give the size over here, so the size of this would be 20 again. And finally I have one more column, which is the salary of the employee. So I'll just type in salary over here, and I'll give in the data type. So the data type again would be 10. So now that this is done, I would finally have to set the primary key. So I'll type primary key over here, and inside this I will pass in the employee ID column. So employee ID, all of this is set. I'll put a semicolon over here. Now let me select all of this and let me click on execute. So we see that we have successfully created a table over here. We see this action over here, right? So now that we have created this table, let's see how can we see the table which we have created right now. So I'll delete this, and to have access at the table we have this command known as select query. So we'll just have a brief glance at the select query. We'll learn about this in detail later. So I'll type in select star from, and then I'll give in the name of the table which I want to have a glance at. So the name of the table is employees. I'll click on execute. So you see that we have successfully created this new table called as employees, which has all of these columns over here. Employee ID, first name, last name, and salary. So guys, we have successfully created a first table named as employees. So that was the create table command. Now let's go ahead and work with the next DDL command, which is the alter command. So as I've told you, the alter command helps us to alter the table. So over here, I want to add a new column into my table over here. So apart from employee ID, first name, last name, and salary, I want to add a new column called as contact. And to do that, this would be the command. So I'll have the keywords alter table, and then I'll give in the name of the table, which is employees over here. So alter table employees. After that, if I want to add a new column, I'll type in add column, and then I'll give in the name of the column, which is contact. And since I've given a new column over here, again it needs to have a data type, so I'll put in int, and the size of this is 10. So let's go ahead and alter our table and add in this new column. So I'll use alter table, and after this I'd have to give in the name of the table. So alter table employees, and I would have to add a new column. So I'll type in add column. Now after this I'll have to give in the name of the column. So the name of the column would be contact, and this is of integer type, and the size or the length of the contact would be 10. Right, so we have successfully added this new column. Let me just hit execute over here. Right, so we have added this. Now let me just go ahead and have a glance at my table again. So I'll type in select star from, I will give in the name of the table, which would be employees. So select star from employees. So as you see, initially we did not have this contact column. Now after using the alter table command, I was able to successfully add this new column. Now let's go ahead and have a glance at our next DDL command. So this time we've got the rename command over here. Let's say if I want to change the name of some column, then I can go ahead and use the rename command. So earlier we had created the contact column. Now instead of the contact name over here, I want to change this to job code. So this is where I can use the rename command. So rename is again part of the alter table syntax. So first we'll add alter table, and then we'll give in the name of the table, which is employees. So instead of adding add column, we'll have rename column over here. So alter table employees, rename column, and I'll give in the name of the column which has to be renamed. So contact and to. So contact would be renamed to job code. So let me go ahead and perform this in MySQL. Let me close this over here. Again, I'll use the alter command. So I'll type in alter command, and after this I'd have to give in the name of the table. So the name of the table would be employees. So alter, so this is actually alter table, not alter command. So alter table employees, and then I would have to give in rename column, because that is what I'd want to do, and I'd want to rename the column contact to job code. So this is done. Let me hit execute, and this is also done. Now let me delete this and let me have a glance at the table again. So I'll type in select star from employees. Let me hit execute now. So as you see, this contact column, or the name of this contact column, has been successfully changed to job code. Right. And then we have this truncate command in DDL. As I've already told you during the theoretical part, this truncate command helps us to remove all of the data which is present inside a table. So the command is very simple. All we have to do is use truncate table employees, and whatever data is present inside this, we can successfully remove. Now we don't have any data inside the table, but still I'll go ahead and show you what happens when we use this truncate table command. So this is our table over here. I'll go ahead and type in truncate table, and after this I'd have to give in the name of the table, which is employees. I'll hit on execute. So you see that we have executed this truncate table employees, and message 0 rows affected because we haven't really added any data inside the employees table. Now let me type in select star from employees, and let's see what is the result. So when I do this, I get the same thing over here, because what this has done is removed all of the data from this table, but we did not have any data. And it also has made sure that the structure of the table remains intact. So this is what happens when you use the truncate command. Now a similar command to truncate is the drop command, which would not only remove all of the data present inside the table, but would also remove the table structure, or in other words, it would delete the complete table itself. So the command is drop table employees. The only difference in the syntax is, so when it comes to truncate, you will type in truncate table employees, and when it comes to drop, you will add in drop table employees. Now let me go ahead and add in the command. So here I'll add drop table, I'll have employees, and let's see what is the result now. So you see that this has been executed. Now let me have the command over here, select star from employees, and let's see what do we get. So as you see over here, table world.employees does not exist, and we get this message because we have actually deleted this employees table. Let me run this again and show you. Again we get the same error because we have dropped this table. Now that we're done with DDL, let's head on to the second type of query language, which is data manipulation language. So as the name states, the data manipulation language would provide you certain commands which would help you to manipulate the data which is present inside your tables. So we've got these three commands in DML, which are insert, update, and delete. So let's start off with the first one over here. So the insert command would help you to insert data into a table. So as simple as that. Let's say you would want to add new records and new rows into the table, then you would want to use the insert command. Now, after you've inserted data into your table, you would want to update certain entries. Now, let's say you would have inserted wrong data. Let's say you would have given the name incorrectly, or maybe if it's the student data set, maybe if you have inserted the marks of the student incorrectly, then you can go ahead and update these values. And apart from insert and update, we also have the delete command in DML query. So delete helps us to either delete one record or a specified record, or maybe all of the records present inside the table. So these are the three commands which are present in DML. Now let's start off with the first one, which is the insert command. So this is the syntax to use the insert command. We'll start off by typing insert into. So these are the keywords. We'll type insert into, and then we will give in the name of the table over here, which is employees. So insert into employees, and then over here we'll give in round braces and list out the names of the columns. So these are the columns which we have in our employees table. I've got employee ID, first name, last name, and salary. And after that, I would give the keyword values, and again I will have this parenthesis, and inside that I'll give in the values. So 101 would go into employee ID, Steven would go into first name, King would be stored in last name, and 10,000 would be stored as the salary. So this is the first record which we have stored in this table. Similarly, we'll use the same command over here. We'll type in insert into, and then give the name of the table, which is employees. After that, over here we'll list out the names of the columns, and then we'll add values, and we'll list out all of the values. So this is the second record over here, 102 Edwin Thomas, and this is the salary of Edwin Thomas. And then similarly, we'll insert the third record into this employees table. So let's go ahead and work with this example. So we are back to MySQL Workbench. Let me just show you the table again. So I'll type in select star from, and the name of the table is employees. Let me hit execute. So this is our table over here, and these are all of the columns which we have. Now I'd want to go ahead and insert my first record inside this. So I'll type in the command over here, insert into, and then I'll have round braces, and after this I'd have to give in the names of the columns. So the first column is employee ID, second column is first name, and then I have a column name which is last name, and finally I have a column called salary. So I'd be inserting values inside all of these. So first the employee ID is, let's say, 1, and then the first name of the employee is Sam, and then I'd have to give in the last name. Now let's say the last name of the employee is Winchester, and salary of Sam Winchester is, let's say, $20,000. So I'll put a semicolon over here. Now what I'll do is I'll just cut it out from over here and I'll paste it over here. Let me just copy it properly. I'll cut it out and I'll paste it at the bottom. Now as you see, we have an error over here because we have not given the name of the table. So let me write in the name of the table. Now obviously if you want to insert records, we'd have to insert records into one particular table, isn't it? So over here the name of the table is employees. So I'm typing out insert into employees. These are the names of the columns and these are the values which should go to the corresponding columns, and I will print out the result. So as you see, we have successfully inserted this record into this table. So we've got 1 over here, Sam as the first name, Winchester as the last name, and salary as this. Similarly, let me go ahead and add 2 more records. Now what I'll do is I'll make changes in this command itself. Now I'll change the employee ID to 2, and I'll change the first name to Dean, last name would be Winchester, and let's say since Dean Winchester is the elder brother, I'll give him a greater salary of $30,000. Now let me execute this. So we have 2 records inside this, and then I have the record number 3, and I'll name this guy as Matt, and his surname is, let's say, Matt Devon, and his salary is $40,000. Let me hit execute again. So I've got 3 records. Let me go ahead and add another record over here. Now I've got Julia, and her surname is, let's say, Julia Aniston. Let me just add Aniston over here, and her salary is maybe $90,000. And I'll just add 1 more record over here. I'll have the ID to be equal to 5, and I'll change the name to be Annie. And after this, I'll add a surname, Hathaway, and her salary is maybe $60,000 over here, and I'll hit execute. So I've got 5 records successfully stored inside this. So now that we're done with the insert command, let's go ahead and work with the next command, which is the update command. As I've already told you, the update command is used to update certain entries in our table. So over here, I am updating the last name. So initially, let me check what was the last name over here. So this was Edwin Thomas. So this guy's last name was Thomas. Yes, it's actually the first record over here. So this guy's last name is King. So his entire name is Stephen King, and I want to change the last name from King to Cohen. So what I'll do is I will use the keyword update, and after that I'll give him the name of the table, which is employees. So update employees, and then I'll write set, and then I will give in the column name which I'd have to change over here. So last name over here and record I'd have to change. After that I'll give in the where keyword, and then I will give in that value, which is the corresponding value over here. So what is basically happening over here is, so where the employee ID is equal to 101, I will go there and update the last name. So this is what this command is saying. If you have any doubts, I'll just repeat it again. So we have to update one particular record, and to update that I am using this where condition. So where the employee ID is equal to 101, I would have to update the last name from King to Cohen. So again, let's go to our MySQL workbench and work with this. So I've got all of this ready over here. Let me remove this. I would just have to give in the update command. So I'll type in update, and after this I'd have to give in the name of the table. So update employees, I'd have to use the set keyword, and then let's say I would want to change the last name of Dean Winchester. So update employees set last name is equal to, so I want to change the name from Winchester to maybe, let's say, Lucifer. So update employee set last name is equal to Lucifer, where his employee ID is equal to 2. So I'll set where employee ID is equal to 2. So we are updating this record and we are printing out the result. Now let me hit execute. Right, so initially this guy's name was Dean Winchester and I have successfully updated this record by using this update command. Now similarly, let's say if I want to update the salary of Julia Aniston over here, let's go ahead and do that. So I'll use the same command, update employees, and I'll have to update the salary. So I'll set the salary over here. Set salary is equal to, so I want to change it from $90,000 to maybe $75,000 over here, where employee ID is actually, so employee ID would be equal to 4. I'll have to remove this and let me hit on execute and let's see what is the result, right? So initially Julia Aniston's salary was $90,000 and I have reduced it to $75,000. So that was the update command. Now we can actually go ahead and delete certain records or delete certain values from our table. So this is the keyword. So we'll type in delete from and then we'll given the name of the table, which is employees. After that, we'll use the where clause. Using the where clause, we will set which column or which record has to be deleted. So here the condition is delete from employees, where employee ID is in 101 and 103. So what will happen is wherever the employee ID is either 101 or 103, those two records would be deleted. So we'll use the same thing over here. So initially we've got these 5 records. So I'll type in delete and then I'll use the keyword from. After this, I'll have to give in the name of the table, which is employees. So delete from employees, where maybe let's say I want to delete the record number 4 over here. So I'll type in where employee ID is equal to 4. Now let's hit execute and let's see what is the result. Right, so as you see, we have successfully deleted the 4th record. Now similarly, if I want to record the second record over here, so I'll type in delete from and I'd have to give in the name of the table, which is employees, where now instead of using the employee ID, I can also use some other column. So I'll set last name is equal to Lucifer. So basically that record would be deleted where the last name is Lucifer. I'll hit execute. Let us see what is the result over here. Let me actually delete this out. Let me run this now. Seems like that is not run. Now let me add it again. Now let me hit execute. The name is Lucifer. Seems like we have an error over here. Delete from employees, where last name is Lucifer. Let me cut this out and let me run this. Okay, so seems like over here I've given 3 is, which was the error over here. Now let me run this properly. Again, we have, you're using safe update mode and you try to update a table. Okay, so we'll have to change this from safe update mode to normal one. Only then we'll be able to delete this. So let me cut this out over here. Let me run this now. So you see this error over here. You are using safe update mode and you try to update a table without a where that uses a key column. Now this happens because this is a safe mode. So to remove this safe mode, you would have to go to edit and you would have to change these preferences over here. Now in the preferences, you will have the SQL editor and over here you see the safe updates, rejects updates and deletes with no restrictions. So uncheck this and now click on OK. So this time when you go ahead and try to delete this, this will work properly. So now let me go ahead and actually run this again. So now that we've removed this, we'd have to actually re-log in. So what I'll do is I'll close this up and then I'll log in again. So I have logged in again over here. Now let me go ahead and try to delete this and let's see what is the result. Right, so this time we see that we have successfully deleted this. Delete from employees, where last name is equal to Lucifer. So when we are working with MySQL, you'd have to keep in mind that if the safe update mode is on, you'd have to uncheck it and only then you'd be able to delete records from your table. Now similarly, let's say if I want to delete another record over here, so let's say if I want to delete this 5th record, now I can go ahead and do that. So what I'll do is I'll type delete from employees, where I'll set the first name. So I'll set the first name to be equal to Annie. Let me just add in Annie over here. Let me hit on run. right? So I have deleted this as well. So that was DML. Now let's go ahead and understand what is data control language. So with the help of data control language, we can basically control the user access to the database. Now, what do I mean by that? Now, whenever we're dealing with data, it is very important that we control which user has access to what part of data, or we have to make sure that only a few number of users or only the important users have access to the important data and other people don't have access to the important data. So this is where we have two commands inside DCL called as grant and revoke. So as it is stated over here, grant gives access privileges to the database and revoke withdraws access privileges given within the grant command. So what this basically means is, let's say if we have 10 users working on one particular database, then I want to make sure that only, let's say, the user number 1 and user number 2 get access to the database to particular records. And let's say if in that database I have a table called employee, and to that employee table I want only the user number 1, 2 and 3 to have access. So what I'll do is I will use this grant command and I will grant the privilege of this table to only these 3 users. So this is how the command will work. So I'll type in grant and this is the privilege list. So whatever privileges, maybe it's the number of records in the table or maybe the entire table or what tables in the entire database that has to be given access to a particular user, right? So this is the entire privilege list. So I'll type in grant privilege list on, and over here I had given whatever table that the user needs to get access to. So grant privilege on relation name to, and here I'll give in the username or the user ID. So this is how I can grant a privilege of a particular table to a particular user. Now this is granting the access. Similarly, we can revoke the access. So what does revoke mean over here? Revoke basically means taking back the access or restricting a particular user to access particular data. So to remove access from a particular user, what we'll do is we'll type in revoke, and let's say if I want one particular user to not have access to the first 3 columns of the student table, then over here I'll give in the privilege list. On, I'll give in the table name to whatever user that is. Let's say if it is user number 10, I'll give in user number 10. So this is how I can make sure that I can grant access to a specified users and I can revoke access to specified users. And then we finally have something known as TCL, which is known as the transaction control language. And these are the 3 commands which come under transaction control language. So we've got commit, rollback and save point. Now before we go ahead and understand what exactly is transaction control language, let's understand what exactly is a transaction. So in simple terms, whatever action you perform, that is known as a transaction. Now let's take a simple example over here. Let's say you go to a bank and you'd want to perform certain operation. So let's say if you want to withdraw money from the bank. So over here, withdrawing money from the bank is a particular transaction. Similarly, if you want to deposit money into the bank, that again is a transaction. And if you want to see balance, how much balance do you have, that again is a transaction which you are performing. Now, in certain cases, it happens that multiple transactions are going on at the same point of time. So this is where you'd have to ensure that the important transactions are committed. And let's say if you have made certain mistake, there's an option to go back to the transaction which you've made. So this is where we have commit, rollback and save point. Now let's say if you have completed one transaction which is very important to you and you want to make sure that this is saved properly. So what you do is you will use the commit command and this will save all of your work till now. All of your transactions which have been done till now would be committed. And similarly, we have the rollback command over here. Let's say you have made an incorrect transaction and you want to roll back to the earlier state. So this is where you can use the rollback command. And there'll be a lot of cases where for now you don't want to save the data, but you consider this to be an important point where you can maybe go back and see your data, what are you working on, or maybe go back and save that particular data. So at those points, you can name that as a save point. So these are the different commands which come under transaction control language. Now let's go ahead and work with the where clause. So many a times it happens that we'd want to extract records from the table on the basis of a condition. So this is where we'll use the where clause. So as it is stated over here, where clause is used to specify a condition while fetching the data from a single table or by joining with multiple tables. And this where clause can be used not just with the select statement, but it can also be used with the update, delete statement and multiple other statements. Now, let's say from this entire employees table, I'd want to extract only that record where the employee ID is equal to 101. So this is where I can go ahead and use the where clause. So what I'll do is I'll type in select star from employees. Now if I just type in this will give me the entire table. So instead of getting the entire table, I'd want only that record where employee ID is equal to 101. So after the statement, I'll use the where keyword and follow it up with the column name and then give the condition over here. So I'll state select star from employees where employee ID is equal to 101. And from this entire table, I'm able to extract this particular row. So let me go ahead and show you the employees table again over here. So I'll type in select star from employees. I'll execute this. So this is our table. This has got 8 rows in total. We've got employee ID, first name, last name, salary and gender. Now out of all of this, I'd want only that record where the employee ID is equal to 3. So after this, I'll type in where and then given the name of the column which is employee ID, I'll give in the condition. So this will be employee ID is equal to 3. I'll execute this and we have successfully got the result. Now similarly, if I want to extract only that column where the employee ID is let's say equal to 5, I'll set 5 over here and let's see what is the result. So this is the employee ID 5 and the name of the person is Nicole Kidman. Now similarly, if I want to extract only that record where let's say the name of the employee is Annie. So over here, instead of giving the employee ID, I'll use the column name first name. So the first name of the employee is Annie. So I have extracted only that record where the first name of the employee is Annie. Now this where clause can be used in conjunction with multiple operators. So we've got the AND operator, OR operator and the NOT operator. Now whenever we want to give multiple conditions, that is, I want to extract records on the basis of multiple conditions, that is when I can go ahead and use the AND, OR and NOT operators. Right? So over here we've got this example over here. So you need to understand how the AND and the OR operator works. So the AND operator gives you a true result when both of the operands are true. That is, whatever is present on the left side of the AND symbol and whatever is present on the right side of the AND symbol, if both of them are true, that is when you'll get a true result. So here let's check this condition properly. So on the left side of the AND symbol, we have 5 is less than 2, which is false. And on the right side of the AND symbol, we've got 5 is greater than 3, which is true. So false and true would give you a false value. So you will get a true result only when both the operands on the left and right side of the AND operator are true. Now let's go to the OR operator. So when you're working with the OR operator, you will get a true result when either of the operands is true or both of the operands are true. So over here we see that 5 is less than 2, which is false. After that we'll type in OR 5 is less than 3. 5 is greater than 3. So since 5 is greater than 3 is actually true, so that is why we'll get a true result. And then we have the NOT operator. So NOT operator is basically opposite of true. So over here we are checking if 5 is less than 2. So 5 is less than 2 will give you a false result and NOT of false will give you true. So if you have a true, if you put in NOT in front of true, you will get a false. Similarly, if you put in a NOT in front of false, you will get a true. Now let's go ahead and work with these sample queries. So let's start with the AND operator. Now from the entire employees table, I'd want only that record or only those records where let's say the first name is equal to Steven and salary is equal to 150 over here, right? Now let's go ahead and work with the AND operator in MySQL Workbench. Let me remove all of this and let me just show you the original table over here. So this will be select star from employees. Now out of this entire employees table, I'd want to extract only those records where salary is equal to or greater than $500,000 and gender is equal to female. So over here, after select star from employees, I'll give in the condition where, so the first condition would be salary needs to be equal to or greater than $500,000. So I'll type in greater than or equal to, and this would be $500,000. After this, I'd have to use the AND operator and I'd have to set the gender. Now the gender needs to be equal to female. So I'll just type female over here. So I've given both of those conditions. Now let me hit execute. So on the entire table, we see that only Nicole Kidman and Angelina Jolie are two employees whose salary is equal to or greater than $500,000 and both of them are female. Now similarly, we have an example for the OR operator over here. So we want all of those employees where either the first name is equal to Steven or salary is equal to here $15,000. So let's work with a similar example from over here. So I'll remove all of this and I'll just print out select star from employees, and this is what we have over here. So from this entire table, let's say I'd want only those records where the employee ID is an even number or gender is equal to female, right? So I'm repeating it again. Either I want only those records where the employee ID is even or gender is equal to female. So let me give in the condition. So for this, select star from employees where, and the condition would be employee ID %2 is equal to 0. Now what I'm doing over here is employee ID %2 is equal to 0. So whatever value is present, I am dividing it by 2. And if I get the remainder 0, then it would mean that the value is equal to 0. Or let's say if I divide 1 with 2, I obviously wouldn't get the result 0. When I divide 2 with 2, I get the quotient 0. When I divide 4 with 2, I get the quotient 0. So this over here would give me the remainder 0. So whenever I get the remainder is equal to 0, that is when I'll use the employee ID %2 is equal to 0. So select star from employees where employee ID %2 is equal to 0. This is my first condition. And then I'll use the OR operator and then given the second condition. So the second condition over here would be equal to gender is equal to female. So let me just type in gender is equal to female, and now let me execute this. Right, so I have extracted those records first where employee ID is divisible by 2. So I've got 2, 4, 6 and 8. Now apart from this, I've also got over here this record employee ID 1 because the gender is equal to female. So apart from 3 and 7, apart from employee ID 3 and employee ID 7, I've got the rest of the records. And then I've got the NOT operator. So as it is stated, we've got the opposite result when we are using the NOT operator. So let's work with the NOT operator over here. So what I want to do is I'd want to extract all of the female employees from this entire table. So I'll type select star from employees where gender is not equal to male. So instead of typing where gender is equal to female, I'm just typing the opposite where gender is not equal to male. And since we've got only two genders over here, male and female, I'll get the opposite result. Similarly, if I want to extract all of the male employees by using the NOT operator, I'll type in the select star from employees where gender is not equal to female. Right, so if gender is not equal to female, and this is what I'll have over here. So those were the basic operators, and apart from this, we've also got the less than equal to, greater than equal to, all of these operators over here. So let's see an example of all of these first. So let's start with the greater than operator. Now let me remove all of this. Let me hit execute. Now from this entire table, let's say I want all of the employees where salary is greater than $400,000. So I'll type select star from employees where salary is greater than, I'll type in $400,000 and let's see what is the result. So I have only 3 records. So Nicole Kidman, Angelina Jolie and Joey Leblo are the only 3 employees whose salary is greater than $400,000. Now this is greater than. So similar to the greater than operator, I have the greater than equal to. So when it came to the greater than operator, this value was exclusive. But when we use greater than equal to, this value would be inclusive. So let me hit execute. And as you see, even this record where the salary is exactly $400,000 has been included. So Charlie Sheen salary is exactly $400,000. Now similarly from the entire table, I'd want to extract all of those records where the salary is less than $300,000. So here I'm setting salary less than $300,000 and I've got 3 employees over here. Anne Hathaway, Brad Pitt and Charlie Harper. So these are 3 employees whose salary is less than $300,000. Now similarly, if I want only those records where salary is equal to or less than $300,000, we just have to put in the equal to operator over there, right? And we also have this record over here, Matt LeBlanc. So Matt LeBlanc salary is exactly $300,000. So these were some examples of all of these different operators. Now we'll work with some special operators. So we've got between, like, as null, in, and distinct. So let's start with the between operator. So the between operator would give you a result within a particular range. So it has to be between a particular range as it is stated over here. Now let's say I want all of those employees where the salary is between 10,000 and 20,000 as shown over here, right? So between this and this. Now you have to understand that both of these are inclusive. So when you type in salary between 10,000 and 20,000, this would mean that 10,000 is inclusive and also 20,000 is inclusive. So let's perform a similar command over here. Let me remove this and let me show you the original table first. So from this entire table, I'd want to extract only those records where the salary is between $200,000 and $500,000. So I'll type select star from employees where salary between, I'll type $200,000 and $500,000 over here. Right, so now let me hit execute and we've got these 4 results. So Brad Pitt's salary is $200,000, which is the lower limit. Nicole Kidman's salary is $500,000, which is the upper limit. And we've got these 2 over here, Matt LeBlanc and Charlie Sheen, whose salary is $300,000 and $400,000. Now, we've got the like operator, which checks an attribute value matches a given string pattern. So this would mean that if I want to extract something where it matches a particular string pattern, for example, from the entire table, I'd want to extract only those records where the first name is like Steven, right? So over here, I'm checking the string pattern. So in the first name, if the string pattern is like Steven, then I'll go ahead and extract all of those records. So let's perform a similar example over here. So initially I'll show you the result again. Now as you see in this, I've got 2 Charlies over here, right? So I want to extract both of those Charlies from this entire table, and for this purpose I can use the like operator. So I'll type select star from employees where first name like, and I'll give in Charlie. I'll put in a semicolon over here. Let me hit execute, right? And I've extracted these 2 records. I've got Charlie Sheen and I've got Charlie Harper. Now, similarly, let's say from this entire table, let's look at the last name over here. So let me see if there's a repeat anywhere. So I've got Matt LeBlanc and I've got Joey LeBlanc over here. Now let's say I want to extract both of these LeBlancs. So I'll type in select star from employees where I'll give in the last name like, and the last name needs to be like LeBlanc. So I'll type in LEBLANC. I'll hit execute and I've successfully extracted these 2 records. Now I'll show the entire result. So let's say if I want to extract all of those records where the first name starts with an A. right? So we can also do that. So I'm repeating it again. From all of these records, if I want to extract only those rows where the first name starts with an A. So I'll type in select star from employees where first name like, and I'll type a percent symbol. This would mean that the first name would start with A and it will follow up with certain number of characters. So when I type in percent over here, this would mean either A is followed by a single character or multiple characters. And this is our result. So we see that we've got two employees whose first name starts with A. We've got Annie Hathaway and we've got Angelina Jolie. Now similarly, from this entire table, let's say I want to extract all of those records where the last name starts with H. So select star from employees where last name like, and over here I'll type in H percent symbol, and that's why I've extracted all of those records where the last name starts with H. So I've got Anne Hathaway and I've got Charlie Harper. So that was the like operator, and then we've got the is null operator, which helps us to extract all of those records where we have a null. But unfortunately, right now, the present table which we're working with, there are no null records, so this is not really of much use for us. And then we've got the in operator over here. So in operator helps us to check an attribute value, and if it matches with any value within a value list. So let's say from this entire employee table, I'd want to extract only those records where salary lies in 10,000, 12,000 or 20,000, right? So basically we have a list, and if I want to extract from that particular list, I can use this in operator. So select star from employees where, let me actually show you the original table again. So I've got this. So select star from employees where, let's say I want the salary to be in $200,000 and let's say $500,000, and I've got $700,000 as well. So from this entire table, I'd want to extract only those records where salary lies in these three values. So I've extracted these three records. I've got Brad Pitt, Nicole Kidman and Joey LeBlanc, whose salary lies in $200,000, $500,000 and $700,000. And after that, we've got the distinct operator, which helps us to extract unique values from a particular table. So when I type in select distinct first name from employees, this would give me all of those records where the first name is distinct. So let me again show you the original table, and in the original table, as you would notice, we have Charlie 2 times. Now I want only the unique first names from this entire table. So I'll type in select star from employees and I'll type distinct first name. And let me put in a semicolon over here. So this is actually the incorrect syntax. So I'd have to type select, and then after this I'd have to give in the distinct keyword over here. So I'll type in select distinct, and inside distinct I would give in the name of the column. So the name of the column would be first name. So select distinct first name from, I'd have to give in the name of the table, which would be employees. So select distinct of first name from employees, and we see that we've got this result. So even though Charlie was present twice, we've got the unique values, and we see that in this result we've got Charlie only once. So after this, we'll go ahead and work with some SQL functions. So these are the basic functions which SQL provides us. We've got the average, count, max, min and sum. Let's say if I want to find out the average value of some numeric column, then I can use this average function. So let's say if I want to find out the average salary of all the employees, then I'll type in select average of salary from employees. So let me perform this command. So I'll type in select, and then I'll give in the function average. So select average of salary from, and then I'll give in the name of the table, which would be employees. So I'll get the result over here. So we see that the average salary of all the employees is around $351,000, 250. Now similarly, if I want to find out the maximum and minimum values, over here instead of average, I'll just put in min max. So select minimum salary from employees will give me the minimum salary, and select maximum of salary from employees would give me the maximum salary. So over here, all I'll do is I'll change this and I'll put in min over here. So select minimum of salary from employees. So we see that minimum salary is $10,000. Similarly, if I want the maximum salary, I'll type select maximum of salary from employees, and we see that the maximum salary is $700,000. And after this, we've got sum over here, which returns the sum of specified column values. Now, if I have numeric values and if I want to find out the sum of all of the records in that column, then I can use the sum aggregate function. So over here, instead of max, I'll just put in sum, select sum of salary from employees, and this is the sum of all of the salaries of all the employees. And then we've finally got the count aggregate function over here. So over here, let's say if I want to find out the total number of rows or the total number of records from the table, then I can use the count star example. So I'll just type in select count of star from employees, and that would give me the total number of records from this table. So I'll just delete this from over here and I'll type in select count of star from employees, and I'll hit execute, and we see that there are 8 records in total. Now let's go ahead and work with a group by clause. Now many a times it happens that whenever we are dealing with tabular data, there are some data, or there is some sort of data which is similar to each other. Now let's say we are working with the student table or the teacher table in the college database. Now from this entire student table, there would be some students who would belong to one particular department, and there would be some students who would belong to some other department. So let's say there are 4 departments in total. You have computer science, you have chemical engineering, you have mechanical engineering, and you have electronics engineering. Now out of all of these, we can place some students under computer science, some students under mechanical, some students under chemical, and similarly the rest of the students into electronics. Now this over here, what we are doing is we are placing students who are in one particular department into one group. So this is where, let's say if we want to extract the marks of all of the students who belong to one particular department, then we need the group by clause. Right? Again, similarly, let's say if we take the employee database or the employee table over here, then different employees would be working in different teams or different departments. Now, let's say there are teams such as marketing, content, tech, sales, and so on. So out of all of these, let's say if we want to find out the average salary with respect to each of these departments. Now, let's say I'd want to find out the average salary with respect to the tech department, with respect to the marketing department, with respect to the sales department, and so on. Again, what I'd have to do over here is group the data with respect to that department and find out the average salary of that particular department. So this is where we'd require the group by clause. Now, as it is stated over here, the group by clause, the group by keyword is followed after the where clause if the where clause is present in a select statement, and it is preceded by the order by clause again if the order by clause is used. Now let's say from this entire table, I'd want to find out the sum of salary with respect to department where the salary of the employees or each of the employees is greater than 15,000, right? Now if we take these 3 departments over here, so we've got department ID 10, 11 and 12. Now over here, if you take department number 11 and department number 12, you see that the salary is greater than 15,000. But when it comes to department ID 10, the salary is actually less than $15,000. So that is why what you will do is you will ignore this department ID 10 and you will only find out the sum of salary of department number 11 and department number 12. So when you sum the salary of department number 11, you only have one record. So that is why you have 15,000 over here. Similarly, when it comes to department number 12, when you add 10,000 and 20,000, that becomes 30,000. So this is how, if you want to find out some information with respect to one particular group or one particular department, you can go ahead and use the group by clause. Now let's go to MySQL and work with the group by clause. So this is our employees table over here. Now what we'll do is we'll go ahead and add a new column into this table, and we'll name that column as department. So to add a new column, we'd have to use the alter command. So I'll type in alter table, and then I'll give in the name of the table, which is employees. And after this, I'll type in add column, and the name of the column would be DEPT. And after this, I'd have to give in the data type of this column. So let's say this is of variable length character and the size is of 20. So we have successfully added this new column. Now let me have a glance at the modified table. So I'll type in select star from employees over here, and now this is our modified table. So we have successfully added this new column. Now I'd have to add the department in which each of this employee works. So for that, I'd have to update the table. So I'll use the update keyword, and then I'd have to give in the name of the table. So update employees, and then I'd have to use the set keyword, update employees set. And then I'd have to, let's say, update the value of department over here. So I'll set department is equal to, let's say Annie works in support. So I'll add support, and over here, update employee set department is equal to support, where employee ID is equal to 1. Now after this, I'll just have a glance at the table. So I'll type in select star from employees. Now let me hit execute and let's see what happens. Right, so we have successfully added the department for Annie. Similarly, I'd want to set the department for Brad. Let's say Brad works in content. So I'll add content over here, and the employee ID is 2. So this has been changed as well. Now I'd have to change the department for Matt, and Matt works in tech. So department is tech and employee ID is 3 over here. This is also done, and then going ahead, I'd have to do it for the rest of the record. So after this, let's say I've got Charlie, and Charlie works in sales. I'll just add sales over here, and the employee ID is 4. Going ahead, I've got Nicole, and Nicole works in content, and the employee ID for Nicole is 5. This is also set. And then I've got Angelina, and Angelina works in tech again. So I'll add tech over here, and the employee ID for Angelina is 6. And going ahead, I've got 2 more records left. So I've got Charlie Harper left, and Charlie Harper, let's say, works in marketing. So I'll add marketing over here, and the employee ID for Charlie Harper is 7. And then I'm just left with 1 employee who is Joey LeBlanc, and Joey LeBlanc works in the tech department. So I'll add tech, and the employee ID for Joey LeBlanc is 8. So we have successfully added all of the departments for all of the employees. And now I'll remove this, and it's time to use the group by clause. Now let's say from this new table which we've just created, I'd want to find out the average salary with respect to each of the departments. So I would have to type in select, and since I want the average salary, I'll use average over here, select average of salary. And since I want this average salary with respect to department, I'd also want to see the department over here, select average of salary, department from employees. After this, I'd have to use the where clause, select average of salary, department from employees, and I don't need the where clause. And after this, I'd have to use the group by clause over here. So I'll type in group by department. Now let me hit execute, and let's see what do we get. Right, so we have the average salary with respect to each of the departments. So we see that the average salary in support is 100,000, in content it is 350,000, in tech it is 533,000, in sales it is 400,000, and in marketing it just seems that the salary is the lowest, which is only $10,000. Now similarly, let's say if I want the average salary with respect to gender, then I can do the same thing. So I'll type in select average of salary, and instead of giving department over here, I'll type in gender from employees, and this time I will group the table with respect to gender over here instead of department, and let me hit execute. So we see that the average salary of female employees is $400,000 and the average salary of male employees is $322,000. Now let's say if I want to find out the maximum salary instead of average salary. Now let's see. So maximum salary with respect to gender. Now let's see if there's any change. So this time we see that the maximum salary with respect to gender. So we see that there is one male employee whose salary is $700,000 and there is one female employee whose salary is $600,000. Now similarly, let's say if I want to find out the maximum salary with respect to department, and over here I'll go ahead and use group by with respect to department. Let's see what difference we would get. So we see that the maximum salary which an employee gets is in tech department over here, right? So in the earlier command, we had seen that one male employee had a salary of $700,000 and it seems that that employee works in the tech department. And after that, again, it seems that the lowest salary is in the marketing department. So it seems like there is one employee and his salary is $10,000. And then in content, we've got someone who earns around $500,000. So this is how we can work with the group by clause. And after group by, we have the having clause. Now, the having clause is used to put up a condition with respect to aggregate functions. Now, normally when we want to use conditions or when we want to extract records on the basis of a conditions, we would use the where clause. But if we want to extract records on the basis of a condition, but that condition is with respect to an aggregate function, then you can't use the where clause, and this is where you would have to use the having clause. So let's understand this command with respect to the having clause over here. Now let's say we have this entire table over here. Now from this entire table, I'd want the average salary where the average salary is greater than $10,000, and this average salary is with respect to department, and I want this only where the count of department ID is greater than or equal to 2. This means that there are at least 2 employees, 2 or more than 2 employees in that department. So in that case, we see that only department ID number 12, right? So where the department ID is 12, only this is the case where we have at least 2 employees in the department. So we have this employee ID, which is 103, and employee ID, which is 100. Now we have this department, and from this department, we'd have to find the average salary. So we have the total salary to be 30,000, and when you do 30,000 by 2, you get an average salary of $15,000. So this is how you can use the having clause and put up a condition with respect to the aggregate methods. Now again, let me show you my table over here. So I'll type in select star from, and then I'll give in the name of the table, which is employee over here. So select star from employees. Now similarly, let's say I'd want to find out the average salary with respect to only those departments where there are at least 2 or more than 2 employees. So what I'll do is I'll type in select average of salary, and I'd also want to have a glance at the department. So select average of salary department from employees, and I'd have to group this with respect to department. So I'll use group by department. After this, I'll use the having clause and I'll give the condition. So having, and as you see, I'm giving the condition where the condition is based on an aggregate function. So having count of department is greater than or equal to 2. So let's have a look at this table. So we see that there are only 2 departments. So the first department is content, where there are 2 employees, and then the next department is tech, where there are 3 employees. So let me run this, and as you see, the average salary with respect to content is $350,000 and average salary with respect to tech is $533,000. And we've got result with respect to only these 2 departments because there are at least 2 employees in only these departments. Now let's go ahead and work with the order by clause. So order by clause is used to arrange our table in either ascending order or descending order. And by default, whenever we use the order by clause, we sort it in ascending order. And if we have to sort it in reverse order, then we'd have to use DESE over here. So let's say we have this particular table over here, and if we want to arrange this table in ascending order, I'd have to type in select star from employees. After that, I'll use the order by keyword. So I'd want to order this table with respect to the salary column. And if I want to order this in descending order, I'll use the keyword DESC. Now let's do the similar thing over here. So let me first have a glance at the original table. So I'll type in select star from employees and let me hit run. So this is our table. Now let's say I want to arrange this table with respect to the descending order of salary. So I'll type in select star from employees and I'll type in order by. I'd have to give in the column by which I'd want to order. So I'd want to order this table with respect to the salary column. And I'd want to order this in descending order. So I'll just add DESC. Now let me hit execute. And as we see, we have ordered this table in descending order. So the first record which you see has the maximum salary and the last record which you see has the minimum salary. Now we'll work with some set operators in SQL. So the first set operator which we'll be working with is the SQL union. So this is used to combine the result set of two or more select statements, and the final result set would have the result without any duplicates. So what this basically means is, let's say if we have two select statements, and with the help of two select statements, let's say with the help of the first select statement, we'd get 3 records. And with the help of the second select statement, we'll get 4 records. Now what we'll do is, we'll find out the result set of the first 3 records and the second 4 records from these two select statements. And if there are any duplicate records, they'll be removed. And what happens with this is, each select statement within the union must have the same number of columns. So let's say if with the first select statement you are using 3 columns, then it is necessary that the second select statement should also have 3 columns. It cannot be less than 3 or more than 3. It should be exactly 3 columns. And also you must make sure that whatever data types of the columns you are using in both the select statements, they must be same. So let's say if in the first select statement, the first column is of integer type and the second column is of varchar type, then you must make sure that it is the same in the second select statement as well. That is, in the second select statement, the first column needs to be of integer type and the second column needs to be of varchar type. So as it is stated over here, you can also use more than 2 queries and you can club them using more than one union statement. So if all of this theory is too much complicated for you, let's understand that with the help of this example. So over here we have 2 tables. So the name of the first table is product 1 and the name of the second table is product 2. And in these 2 tables, we have the same column. So in product 1, we have category ID and product name. Similarly, in product 2, we have category ID and product name. Now, what we are doing is, with the first select statement over here, we are selecting the product name column from this product 1 table. Similarly, from this select statement, with the help of this select statement, we are selecting this product name column from the product 2 table. So this select statement would return us Nokia, Samsung, HP and Nikon. And similarly, this select statement would return all of these values from this table. Now, when you use the union operator in between these two, this will give us the result set of both of the select statements. So that would mean whatever common values are there, those will be removed. So from this, we'll get Nokia, Samsung, HP and Nikon. And from this, whatever extra are there. So LG, Dell, Apple and PlayStation. So these are the ones which are not present in product 1, right? So basically, when we use the union operator, we'll get the result set of both of the select statements. So let's go to MySQL and implement the union operator. So my first task over here would be to create those 2 tables. So I'll type in create table and the name of the first table is product 1. And inside this, so the category it is let's say category ID. This is the name of the first column, and then I'd have to give in the name of the second column, which would be product name. And this is of integer type, and let's say the length is 10. Similarly, product name, this is of varchar type and this is of length 20. So let me go ahead and create the table. So we have successfully created this table. Now let me have a glance at what I've just created. So I'll type in select star from product 1. So we see that we have the structure of the table over here ready. Now it's time to insert the values. So I'll just type in insert into product 1, and over here I'd have to give in the names of the columns. So the name of the first column would be category, and I'd have to give in ID over here. So I'll just type in underscore ID, and then I'd have to give in the name of the second column, which would be product name. And after this, I just have to type in values and give in the values over here. So I'll give in 1, and then let's say the first product is Nokia. So let me just type in Nokia over here. Let me cut this and paste it below the insert statement. Right, so we have successfully inserted the first record. Now similarly, let me go ahead and add other records as well. So I'll type in 2, and then over here I'll add Samsung. And after this, I'll go ahead and insert a record, and that would be HP. So let me just add HP over here. And after HP, I would have at category ID 6, this would be Nikon. So let me just add Nikon over here. So this is my product 1 table. Now similarly, I'd have to go ahead and create product 2 table. So I'll type in create table product 2, and inside this the name of the column would be the same, which would be category ID, and this is of integer type, size is 10, and then I'd have to give in the name of the second column, which would be product name, and this is of varchar type again, and since there's a variable length character, the length would be 20. Let me execute this over here. So we have created this table, and now let me have a glance at product 2. So select star from product 2, and this is our product 2 over here. Now it's time to insert values into product 2. So I'll type in, let me actually cut this over here, and I'll type in insert into product 2. So the names of the columns are same. Now I'll have to go ahead and insert the values. So category 1 in product 2 would be Samsung. So let me just type in Samsung over here. We've got this set, and then category 2 would be LG. Let me type in LG. Then we've got HP at category number 3. So let me also add HP over here. Then at row number 5 or category number 5, we've got Dell. This is also set. Then at category ID 6, I've got Apple. So let me remove this, and I'll also add Apple over here. I'll hit on execute, and then going ahead, I'll add the final record, which would be category ID 10, and this is a PlayStation. So let me just add PlayStation over here. I need to put a comma after this. Now we have created product 1 and product 2 tables. Now it's time to extract the records which are common in product 1 and product 2. So I'll type in select product name from, and then the name of the table is product 1. After this, I'll use the union operator, and I'll use select product name from, and then this would be let me get the spelling properly over here. So this would become product 2. I'll hit on execute, and so this is the final result over here. So this is the result set of both of these select statements. Now similar to the union operator, we've got the union all operator. So this is used to combine the results of two select statements including duplicate rows. So this is the only difference between union and union all operators. So when it comes to the union operator, the duplicates are not included, and when it comes to the union all operator, the duplicates are included. And as it is stated over here, the same rules that apply to the union clause will also apply to the union all operator. And this is the syntax for union all operator. So you will first give in the select statement. You'll list out the columns which you would want to extract from table 1. After that, you will give in the keyword union all, and you will give in the second select statement and list out the same set of columns in the same order from table 2. So if you see over here, we've got product 1 and product 2. These are the same tables, and when you apply the union all operator on these two tables, this is what we get. So this is the result from first select statement. So we have Nokia, Samsung, HP and Nikon. And after that, from the second select statement, we have this Samsung, LG, HP, Dell, Apple and PlayStation. So as you see over here, the duplicate values are also included. So Samsung over here comes 2 times. So as you see over here, Samsung comes over here 2 times. Now let me just change this from union to union all and let me hit on run and let's see the result. Let me increase the size of this over here. So as you see, we have Nokia, Samsung, HP and Nikon, and we also have the duplicates from the second table. Now we'll understand the concept of joins in structured query language. So many times it happens that we'd want to combine different tables into one single table so that we may have a glance at all of the records at one single place. So if we take that example of the college database and let's say if we have the student table and the teacher table inside that college database. Now there'd be some properties which we'd want to see from the student table and also from the teacher table at the same point. So let's say if we want to see which teachers teach to some particular students or which teachers teach to some particular department. Now if that is the case, then we'd want to combine the teacher table and the student table into one single table so that we may have more information at the same time. So this is where we can use the joins in SQL. So another similar example would be, let's say if we have the company table or the company database, and inside the company database we would have the employees table and the departments table. Now there'd be some situations where we'd want to see the employees table, the information in the employees table and the information in the departments table at the same time. So again, the best option would be to combine these two tables into one single table and have all of the information in that table. Now for that purpose, we have different joins in SQL. So we have inner join, left join, right join, full outer join, and a lot more. So let's understand all of them. So what does a join actually do? Let's understand that first. That is stated over here. With the help of joins, we can combine rows and columns from 2 or more tables based on a related column between them in a database. So what this basically means is, let's say if we have a table A and table B, then what we are doing is we are trying to combine the rows or columns from table A and table B on the basis of a common column which is present in both table A and table B. So this is one important information which you guys have to note over here, guys, right? So there has to be at least one common column between table A and table B. Only then you'd be able to apply these joins on these two tables. So first let's go ahead and understand inner join. Now for inner join we would need two tables, absolutely, table A and table B. And what happens in inner join is this returns when there is a match in both tables. This would mean that, let's say if we are trying to combine table A and table B on the basis of a condition, then this would return all of those rows wherever the condition is satisfied or wherever there is a match, right? So let's say if there are 10 records in table A and 15 records in table B, and out of those 10 and 15 records, let's say 5 records match. And now on the basis of that condition, you will only get those 5 records which satisfy the condition between table A and table B. So this is known as inner join, which only return the matched records. And after inner join, we have something known as the left join. So in left join, we get all of the records from table A irrespective of whether the condition is satisfied or not, right? So we get all of the records from table A or from the left table, and only the matched records from table B or from the right table. And when it comes to the right join, it's exactly opposite of the left join. So in right join, we get all of the records from the right table or from table B, and only the matched records from the left side of the table or the table A. Now going ahead, we have something known as the full outer join. So full outer join would give you all of the records from table A as well as all of the records from table B. And then we finally have the self join over here. So self join is used to join a table with itself. So now the question which arises over here is, how can you actually join a table with itself? So you just rename the table as something else. You have a temporary table. So as it is stated over here, Self join is used to join a table to itself as if the table were two tables, temporarily renaming at least one table in the SQL statement. Now let's say if you have a table called as A, what you do is you try to join A with A itself, but then again you rename A as something else. And then we have the last join, which is known as the Cartesian join or the cross join. So this cross join returns the Cartesian product of the sets of records in these tables. So this would mean that if there are 3 records in table A and 4 records in table B, and if you apply the cross join on these two tables, then the final table would have 12 records in it. This would be because 3 into 4 would give you the Cartesian product, which is 12, and the final result would have 12 records in it. Now let's start off with the first one, which is inner join. As I've already told you, inner join would give you all of the common records or all of the matched records in table A and table B. And this is the syntax to apply inner join on two tables. So first we'll start with the select keyword. After giving the select keyword, we will give in the set of columns which we'd want to extract. So let's say if we want to extract column 1 from table 1, we'll first give in the name of the table, we'll use the dot operator and then give in the column name. Similarly, if we want the column 2 from table 2, then we'll give in the name of the table, we'll give in the dot operator and then we'll give in the name of the column from this table. Similarly, we'll give all of the columns from all of the tables which you'd want. So let's say if I want column n from table 1, I'll give in table 1 dot col n. So once I've listed all of the columns which I want from table 1 and table 2, after that I'll give in the from keyword and give the name of table 1 or the left table. And I'll give in keywords inner, join, and I'll give the name of the second table or the right table. Now once all of this is done, I'll use the keyword on and then give the condition on the basis of which I'd want to join these two tables. So over here the condition is table1.common field needs to be equal to table2.common field. That is, wherever the records in this column of table 1 is equal to wherever the records of this column in table 2 are equal, all of those records I'd want to extract. So let's go ahead and apply this concept of inner join in MySQL. So let me go back. So initially we had the employees table over here. So let me just show you guys that employees table. So select star from employees and this is our employees table. Now to apply all of the different joins which you have just seen, I would need one more table. So for that I need the department table. I'll go ahead and create the department table for that purpose. So I'll type in create department and inside this I need certain columns. So first, let's say I would need the department ID column. So over here I'll type in department ID and this is of integer type and the length is 10. And then I would need the department column, which is the common column over here. So I have the department column in the employees table as well. So this would be my common column. I'll set varchar of 20. And then after this I'd have maybe the department location column. And again, this would be of type varchar and I'll set 20 to this. So this is how I am able to create this table called as department. So seems like we have an error over here. So create and after this I'd have to type in table. So this was the error. Now I'll type in select star from department. Let me hit execute and let's see what do we get. So we see that we have successfully created this table called as department. Now it's time to insert values into this table. So let me go ahead and insert some values. So for that I'd have to use the insert command. So I'll type in insert into, have to give in the name of the table which is department and then I'll have to set the column names over here. So this would be department ID. After department ID I just have department and then I have the department location. And I'll go ahead and set the values. So let's say the first department ID is 1 and the department is content and the content department, let's say, resides in Chicago. Now let me cut this and let me paste it over here. Let's see what is the result. So we have successfully created our first department. Now I'll go ahead and create my second department over here, which would be support. So department ID is 2 and name of the department is support, and let's say support department is in New Jersey. So let me just change this to New Jersey over here. This is also set. Now I'll go ahead and create the third department, which would be sales. So I'll add sales over here, and after this, let's say the sales department sits in Boston. I'll add Boston over here. I've got this to ready, and I'll go ahead and add 2 more records. Now let's say the fourth department is the HR department, and I'll add HR over here, and let's say also the HR department sits in Chicago. And then I'll add 1 more department, which would be operations. So I'll set the ID to be equal to 5, and I'll add operations over here, and operations is in New York. So let me just add New York over here, and my department table is finally ready. And now that I have both of these tables ready, I would want to apply the inner join on this. So I'd want, since I'm applying the inner join on these 2 tables, I'd want only those records where the department is common in the employees table and as well as the department table. So let me go ahead and write the command for that. First, I'd have to give in the select keyword, and then I'd have to list out all of the columns which I'd want from the employee table. So first I'll use the alias. So I'll type in E dot, and after this, let's say I would want the first name from the employee table. I would also need the last name from the employees table. So I'll add E dot, let me add last name. And apart from this, let's say I'd want the department name and the department location columns from the department table. So I'll type in d.dept, and I would also need d.dept location. So these are the 4 columns which I'd want from both of these tables. And after this, I'd have to give in the from keyword and give in the name of the first table, which is employees, and I'll set the alias E. So this E, what you see is basically I am extracting the first name and the last name columns from the employees table. So this is the alias which I've given to the employees table. And after this, since I'm applying inner join, let me just add inner join over here, and I'd have to give in the name of the right table, which is department, and I'd have to give in the alias for department, which is D over here, right? So I'm extracting the department name column and the department location column from this department table. And after that, I'll finally give in the keyword on, and I'd have to set in the condition. So the condition would be E dot DEPT is equal to D dot DEPT. That is, the department name column needs to be same in both of those tables, or in other words, wherever these records are common in the department table and the employees table, I would want only those records. So let me go ahead and execute this. And this is our result. Now let me just elongate this, and this is what we have. So it seems that the common departments are support, content, sales, and again we have content over here. So it seems like these are the only common departments over here. And with respect to this, I have extracted these people. So Anne, Brad, Charlie, and Nicole. So these are the people which basically occur in the same departments. Now, just to be sure, I'll also have select star from, and then let me give in the department table over here. Select star from department. Let me run this, right? So as you see, we have the content, support, these 2 departments over here. Now let me run this, and I've got content, support, and sales, right? So these are the 3 departments. Content, support, and sales are the 3 departments which are common in both these tables. So we have applied this inner join. Now it's time to work with the left join. So as it is stated over here, when we apply left join, we get all the records from the left table and only the matched records from the right table. And wherever there is no match, we will put in null values in the right side, and the syntax is pretty much the same. First we'll give in the select keyword, and after that we will list out the set of columns which we'd want to extract from table 1 and table 2. After that we'll give in the from keyword and give the name of table 1, and then we'll type left join and then give the label of table 2. After that we'll type on and then give in the condition on the basis of which we'd have to join these two tables. So this is our example of left join over here. Let's say we have this employees table and this department table over here, and I'm applying this left join, and the condition is wherever the department ID is common between these two. So over here, let's say I've got 10, 11, 12, I've got 10, 11, 13 and 14. Now since this is left join, I'd get all of the records from this left table. So that is why, as you see over here, I've got Harry, Edwin, Steven and Eric. All of these are there. And from the right side of the table, let's say wherever this is not present, so 12, wherever 12 is not present, I get null value. So the ID is 103 and 100. So as you see over here, 103 and 100. So as these two employees or these two records are not present in the department table, I have a null value over here. And wherever the records are common, obviously I get the records from both the tables. So let's go ahead and apply a similar operation on the employees table and the department table in MySQL. Now, obviously the command would be select, and I'll type in E. I'd want the first name, and after the first name I'd want the salary. So select E dot first name and I'll type E dot salary, and from the department table I'd want DEPT, which is the department name, and I'd want the department location. So I'll type D.DEPT underscore location. So this is actually LOC. Now that I've given the list of all of the columns which I'd want to extract, I just have to give in the from keyword, and I'd have to give in the name of the first table, which is employees, and the alias is E. Now that this is done, I'd have to give the left join, because that is what I'd want to apply on these two tables. I'll type left join and I will give in the name of the second table, which is department, and I'll give in the alias, which is D. After that, I'd have to give in the on keyword and I'd have to set in the condition. So the condition is wherever these columns are equal, or the records in the department column are equal. So this would be E.DEPT is equal to D.DEPT. I'll put a semicolon and let me hit run, and this is what we have. So 1, 2, 3 and 4. So these 4 records which you see, so these 4 records are where the condition is satisfied. That is where the department is common in the employees table as well as the department table. Now these records, the rest of the records which you see, these are part of the left table. But since this department, whatever department these guys belong to, that department is not present in the department table. So that is why we have a null over here for the last 4 values. So I'll repeat it again. So for the first 4 values, the condition is satisfied, and for the last 4 values, the condition is not satisfied. And since this is the left join, that is why we have all of the records from the left table and we have the null values from the right table over here. Now after that, we have the right join. So the right join is exactly opposite to the left join. So in right join, we would have all of the records returned from the right table, but only the match records in the left table. And this is the syntax. So again, we'll type select, we'll list down all of the columns from table 1 and table 2. From table 1, right join table 2 on, and then we'll give in the condition on the basis of which we'd have to join these 2 tables. And over here, we've got the employee table over here, department table over here. And I'd want to join these 2 tables on the basis of where the department ID is equal. And since this is the right join, I'm getting all of the records from the right table over here, as you see. And wherever this is not satisfied, right, wherever the department ID is not equal, there I am getting the null values over here. So I have 10, 11, 13 and 14. So as you see, 13 and 14 is not present over here. So this is resources and shipping. So these 2 records wherever are there. So for these 2, I have null values from the left side of the table. So I'll delete this and let me write the command for this as well. So I've got the employees table and as well as the department table ready. First, I'd have to type in select and I'd have to list down the set of columns. So let's say now instead of the first name, I'd want the last name. So I'll type in e dot last name. And from the department table, I'd want the department and I'd want the department ID. So I'll type in d dot dept ID. These are all the columns which I'd want. And let's say I'd also want the gender over here along with this. So I'll type in e dot gender. After that, I'll put in from and then the name of the first table, which would be employees, the alias. Once I give the alias, I'd have to type in right join because that is what I want, and then the name of the second table or the right table, which is department. Now that this is done, I'd have to give in the on keyword and set the condition, which is e dot dept should be equal to d dot dept. I'll put in a semicolon, let me hit run, and this is what we have over here. So this is right join, and as you see from the left side of the table, I've got last name and gender, and from the right side of the table, I've got department and department ID. And since this is right join, I've got all of the records from the right side of the table, and where the department condition is not satisfied, I have got null values. So HR department and operations department is not present in the employee table, and that is why I have null value over here. And then finally, I've got the full outer join, which combines the results of both left and right outer joins. So the join table will contain all the records from both the tables, and wherever the match is not there, we will be returned with nulls. And this is the syntax. So as we are combining the results of both left and right outer joins in full outer join, what we'll do is we will first use the syntax for left join, and we'll use the union operator and we'll union it with the results of the right join, right? So we had earlier learned the concept of union. So what we'll do is we'll just use this union operator between the left join and the right join, as this combines the results of both the left join and the right join. So again, we've got this table over here. This is the employees table and this is the department table over here. So first we will give in the entire syntax for the left join. After that, we'll put in the union operator, and then we'll put in the entire syntax for the right join. Now, as you see, this is the resultant. So first, since we've put in the left join, we've got all of these 4 records from the left join. And since there is not satisfied over here, so we have null. And after the union operator, we've got the right join. So we've got these 2 records from the right join. And since these 2 departments are not there, we have the null value. So let's go ahead and put in the condition. So let's say for this, I'd want everything. So e dot last name is already set. So I'd want e dot first name. So let me put in e dot first name, e dot last name, e dot gender, and I'd also want salary for this. So I will just write e dot salary, and from the department table, I'd want the department name, the department location, and the department ID, all of these. So basically, I'm extracting all of the columns from the employees table as well as the department table. So first, I will give in left join over here. Now, once I give in left join and the condition over here, I'd have to use the union operator, and I will select the same command over here. I will paste it over here, and in the second half of the command, instead of using left join, I'll just keep it as right join. Now let me remove the semicolon and I'll put it at the end of the command. Now let me hit execute and let's see the result. So it seems like we have an error over here. So we don't have a department called DLOG. So this is actually DEPT-LOC. Let me change it to DEPT-LOC and let me hit run. And this is our result. So this is how full outer join looks like. So as you see, first we have applied the full join. First we have applied the left join. So that is why we have all the records which are common in these 2. So the content department and support and sales are common in these 2. And after that, we have got these records which are present in the employees table but are not present in the department table. So as you see over here, So we've got these members. So Matt, Angelina, Charlie, and Joey. So these are present in the employees table, but they're not present in the department table over here. And finally, we've got two new departments, HR and operations, which are not part of the employees table. So now that full outer join is done, we are just left with one join, which is the cross join. And as I've told you, the cross join would give you the Cartesian product of all of the rows in table A and table B. And this is the syntax for it. Select, I'll give in the list of the columns which I'd want from table A and table B. After that, I'll put in from table 1. And then I'll just type in cross join table 2. So let's say if I have table 1 and table 2 like this. And if I apply cross join on these two, since there are 4 records in table 1 and 3 records in table 2, so cross join is basically 4 cross 3, and this is what I have over here. So what this basically gives is for every record in table 1, I have these 3 results with respect to this. So first I have A1, then I have A2, then I have A3 over here, right? Similarly, I have B1, B2, B3, C1, C2, C3, and D1, D2, and D3. So this is how I'll get the result. So let's go ahead and perform this in MySQL. Let me remove all of this. Let me also reduce the size of this over here. Right, so select star, since I want all of the records from both the tables. So select star from the first table as employees, and after this, since I want to apply cross join, that is what I'll put in over here. And then I'd have to give in the name of the second table, which is department. So select star from employees, cross join department. I'll put a semicolon, and let's just hit enter, and this is our result. So this is, as you see over here, so these are the total number of records which we have. So now that we've learned all the major concepts of SQL, it's time for the lab exercise. So we'll be going through a bunch of questions and we'll be performing all of these questions in MySQL Workbench. So we'll start off with our first question over here. So we'll have to start off by creating a database with the name bank. Now till now we haven't seen actually how to create a database. We've only seen how to create a table and insert data into that table. So the syntax to create a database is actually very simple. All you have to do is use the keyword create and then follow it up with the keyword database. After that, you will give in the name of the database which you would want to work with. So you'll type in create database, and since I want to work with the bank database, I'll give in bank. So I'm here at MySQL Workbench. So here what you see on the left side column, these are all of the list of databases which we have. So as of now, we've got World, Sys, and Sakila. So now we'll have to create a new database with the name bank. So I'll type in create, and after this I'll give in the keyword database, and I'd have to follow it up with a name of the database. I'll give it as bank. Now let me refresh over here. So we see that we have successfully created this database called as bank. Now if we have to create tables into this database, so till now we were actually working with the world database where we were inserting all of our tables into this database. But now I'd have to change my database from this to this. So I'll just delete this over here, and now I'll give in the name of the database which I want to work with. So I'll type in use, and then I'll give in the name of the database which is bank. So now we are into the database, we are into the bank database, and we can create all of our tables in this bank database. Now let's head to our second question. So in the bank database, we'd have to create a new table called as bank details. And this bank details table will comprise of following columns. We'll have product, quantity, price, purchase cost, and estimated sale price. And these are the data types of all of these. So product will have a string data type, quantity with numerical data type, purchase cost with decimal data type, and estimated sale price with a float data type. And this is the solution which you see over here. So starting off, we'd have to type in create table and then given the name of the table, which is bank details. Now after that, we'll give in the name of the first column, which is product. And if it is a string, we can either set it to be char or varchar. So char is a fixed length string and varchar is a variable length character. And we are setting the size to be 10. Then we want quantity, which is of data type int. And then so you see the difference over here, numerical and number. So number you can represent it with real, and numerical you can represent it with int. So in int, you only have integer values, and real values obviously comprise of all of the real values over here. After that, we have the purchase cost, which is of decimal data type. So to create decimal, we'll type in decimal, and after that, we'll give in inside the parenthesis, we are giving in value 6, 2. So the 6, 2 is the maximum length of the value which we are giving in it, and that would comprise of 2 decimal places at max, right? So in total, the maximum length could be 6, and in that all of those 6 values, there could be only 2 decimal values or 2 values after the right side of the dot. And then we finally have this column called as estimated sale price, which is of float type over here. So let's go to MySQL and create a new table over there. So I'd have to create a table. I'll type in create table, and the name of the table is bank details. Now I'll put in parenthesis over here, and inside this I just have to give in all of the names of the columns and the data types. So the first column would be product, and this is of char type, and the length is of 10. Going ahead, I'd have to create another column called as quantity, and this is of integer type. After this, I'd have to create price column, and this is of real. And then I have the purchase cost, so I'll type in purchase cost over here, and purchase cost is actually decimal, and this would be 6, 2. And I have my final column, which is estimated sales price. So I'll just type in estimated sales price over here, and let me actually keep it as estimated sale price and not sales price, and this is of float type, and I'll put in a semicolon, and let me just hit execute. So this is float, FLOAT. Right, so we have successfully created our table with the name bank details. Now let me just have a glance at the table which I've just created. So I'll type in select star from, and over here I'll give in bank details. Now let me hit execute, and let's see what is the result. So these are all of the columns which are present in this table. So now that we have created the table, we'd have to display all of the columns and their data types in the bank details table. Now, if we just want to see the names of the columns, we can use select star command. But if we want to also see the structure of the table, then we'd have to use the describe command over here. So we'll use the keyword describe, and then we'll give in the name of the table, which is bank details. So that is what I'll do over here. I'll start off by giving the keyword describe, and after this I'll give in the name of the table, which is bank details. Now let me have a glance at the structure of this, and this is what I have over here. So these are all of the names of the columns, and this is the data type. So now that I've done this, I'd have to go ahead and insert records in this table. So basically I'd have to insert 2 records. So the first record would comprise of all of these values. So as you see, we have the corresponding values of product, quantity, price, purchase cost, and estimated price. So this is record number 1. And similarly, we'd also have to insert the record number 2. So to insert values into a table, we'd have to use this keyword. We'll type in insert into, and then we'll give in the name of the table, which is bank details. And after giving the name of the table, we'd have to use the keyword values, and we will give in the corresponding values inside this. So now let me give in the command. So I'll type in insert into, and then I'd have to give in the name of the table, which is bank details. So I'll type in bank details over here, and after that I'd have to use the keyword values. And let me go ahead and just give in all of the values over here. So let's say first we've got product, and the first product is, let's say, pay card, and after that we've got quantity is, let's say, 3. Then I've got price, which is, let's say, $330, and then I've got purchase cost, which is, let's say, 8,008, and then I've got estimated sale price, which is, let's say, 9,009. So this is my first record. Now similarly, I'll go ahead and insert a second record into this. So I'll type in insert into, let me write it properly over here, insert into bank details, and after this I'll type in values, and inside this I'd have to give in the details. So the first or the second product over here is actually pay points. After this, I've got the quantity, which is 4, and then the price is, let's say, $200, which is lesser than the first product, and then the purchase cost is 8,000, and after this, I'd have to give in the sale price, which is 6,800. Now let me go ahead and execute this. So we have inserted these two records. Now it's time to have a glance at the modified table. So select star from, the name of the table is bank details, and I'll hit execute. Right, so I have successfully inserted these two records inside this table. Now after that is done, I'd have to make some changes to the table. So further going ahead, I'd have to add a new column to this table. So I'd have to add this column called as geolocation, where the data type is varchar with a size of 20. So the command would be alter table, and then I'd have to give in the name of the table, which is bank details. Then I'll use the keyword add, since I'd have to give in a new column, and I'll give in the name of the column, which is geolocation, followed by the data type of it. So let me go ahead and work with the alter command. So I'll type in alter table, and the name of the table is obviously bank details, and I'd have to alter this by adding a new column. So add of, I'll type in geolocation, and this is of varchar 20. So I have altered the table. Now it's time to have a glance at the modified table. So it'll be select star from bank details. Now if I hit execute, so as we see, initially we did not have this geolocation column, and by executing this command, we have successfully added this new column into this. Now further going ahead, we'll have to check the length of the string over here. So we want to find out what is the value of geolocation for product pay card. So wherever we have the product pay card, I would want to find out the value of geolocation. So what we'd have to do is we'd have to use the where clause. So we'll type in select geolocation from bank details where product is pay card. So basically the question is this: wherever I have the product of pay card, I would want to know the geolocation corresponding to this. So the command would be select geolocation from, and I'd have to give in the name of the tables, which is bank details. Select geolocation from bank details where product is equal to pay card. We actually have a null value because there is nothing stored in geolocation, because it is a new column and we haven't added any value inside that. Now further going ahead, we'll have to find out how many characters does the product pay card have in its bank details table. So in this, let's count the number of characters over here. So we've got 1, 2, 3, 4, 5, 6 and 7. So to get the exact number, we'd have to use the char length function. So this is a string function which is inbuilt in SQL. So we'll type select char length, and inside this we will pass in the column name for which we'd want to find out the length. So we'll pass in product inside this, and we'll type from, given the name of the table, which is bank details, and then we'll give in the condition over here where product is equal to pay card. So let me show you the table first over here. So it will be select star from bank details, and we have our table right in front of us. Now I'd want to find out the length of this, so I'll type in select of char length, and I'd want to find out the char length of product. Select char length of product from bank details. I'd have given the condition where I'd have to give product is equal to pay card. Right, now let me select this and let me hit on execute. So seems like we have a error over here. So this is actually product. So there's a spelling mistake over here. Now let me hit execute. So we see that the char length is 7. Now similarly, let's say if I want to change this and if I put in points over here, which is basically the second record. Now we see that the length is 9. Now if I remove this condition and just put in a semicolon, now let's see what is the result. So we get 7 and 9 because the character length of pay card is 7 and the character length of pay points is 9. And then going ahead, we have our new question over here. So we'll have to alter the product field from char to varchar. So initially when we had created this bank details table, the data type of this product column was character. So we'll have to change that from character to varchar, which is a fixed length character, to a variable length character. So we'll again use the alter table command over here. So we'll type alter table given the name of the table, and instead of using add, we'll have the command over here modify, because we want to modify the table. Modify product, which is the name of the column, and given the data type. So again, I'll remove all of this over here. Let me use describe first so that it's easier for me to look at the table. So I'll type in describe and I'll give in bank details. So I basically have to modify this column over here. So this is char. I want to change this from char to varchar. So I'll use alter table and then the name of the table is bank details. And I'd have to use the keyword modify, and then I'd want to modify the product column. And from char, I want to make it to varchar, and the length would be same, which is 10. Let me cut this out. Let me run this now. Have we successfully executed this? Let me again run this and let's see what is the result. Right. So now we have successfully altered the table. Now let me go ahead and use describe again. So I'll type describe bank details, and now when I hit on execute, we see that initially this was char. We have successfully changed this to varchar with the help of the alter table command. Now after doing this, I'd want to reduce the size of the product field. So as you see, we had set the size to be equal to 10. Now I want to change the size from 10 to 6. Now after doing that, I actually want to see if this is actually possible. So again, the command would be same. I'll type in alter table given the name of the table, which is bank details over here. So I'll type in alter table bank details, and I'd have to use modify, and the name of the column is product, and varchar, and instead of giving 10, I'll put in a 6 over here. Now let me hit run. So we see that this is an error. We have an error over here, and it states data truncated for column product at row 1, because we already have inserted 2 records into this table and the length of both of those characters was 7 and 9, which means we need to have the size over here at least to be 9. So let me change all of these values and show what happens. When I put it to be 7, again I get an error. When I put it to be 8 and run this, again, as you see, we have an error. Now finally, when I put it to be 9, you see we have successfully applied this to 2 rows over here. And now just to ensure that we have made the changes, I'll type describe and then given the name of the table, which is bank details. So as you see, we have changed this size from 10 to 9. And after doing this, we'd have to create a new table called as bank holidays. And this new table again would comprise of 3 columns. So we've got holidays, start time and end time. So holiday field displays only the date, and then we've got start time which displays hours and minutes, and then we've got end time which displays hours, minutes and time zone. So to create a column which comprises of only date, over here as you see inside the create table command, first we'll give in the name of the column and then we'll set in the data type. So over here to display only date, we'll use date over here. And when we want date and time, so when we want time in hours and minutes, we'll use date time. And then when we also want the time zone, we'll use the timestamp data type over here. So let's go ahead and create this table. So again, we'll be creating this table inside our bank database. So create table, and the name of the table would be bank details. And inside this, I'd have to just go ahead and create all of these columns. So the first column would be holiday, and its data type would be date. And after this, I'd have to give in a new column called as start time, and this would be date time. And going ahead, I'd have to create a new column called as end time, and for this it would be timestamp. So I have successfully created this table. Let me hit execute. So seems like, oh yes, so this is actually not bank details and this is bank holidays. So let me change this to be bank holidays over here, because even employees of a bank need holidays. They can't work every single day, right? So I have created this table. Now let me just show you the table which I've just created. So select star from bank. Let me type in holidays over here. And this is our table which we've created. So now that we have created the table, we'd have to insert records in it. So first, we'd have to insert today's details in all of the bank holidays. So to insert today's details, which is basically the first, we'd have to insert the date and then start time and end time. So all we'd have to do is put in current date, and current date inside this. So we'll start off by using insert into bank holidays, because we'll have to insert a record inside this. And after this, current date will give us the date, and over here current date and current date will give us the timestamp and the date over here. So let me do this. So I'll type in insert into bank holidays values, and I'd have to give in current date. Again, it will be current date, and then the third again would be current date. Now let me run this. Now let me have a glance at this table now. So I'll type in select star from bank holidays, and let's see what is the result. So as we see, we have added all of these details. So today's date is 28th April, and this is the start time and the end time which you see over here. And after this, we have a step 2 over here. So we'd have to postpone holiday to next day by updating the holiday field. That is, we had inserted the date to be 28th of April, and I want to change that date from 28th of April to 29th of April. And since we are actually updating a record in the table, we'd have to use the update command. So we'll type in update, given the name of the table, bank details, given the keyword set, and now to update a date field, we'd have to use this method called as date add. And this takes in 2 parameters. So the first parameter is the column which we'd want to update, and in the second parameter, we'll add by how much we'd want to change this. So either if you want to change this with respect to days or hours or minutes or anything over here. And since we do want to increment this by 1 day, I'll add interval 1 day. So whatever date is stored inside this record, when I put in interval 1 day, it would be incremented with 1 day. So let me go ahead and perform this. So I'd have to type in update bank details set, and after this I'd have to update the holiday column. So I'll type in holiday is equal to date add, and I'd have to modify the holiday column. Let's say if I put in interval 1 day over here, I'll put in interval 1 day. And after this, let me see what happens. I'll put in select star from, and this is actually bank holidays and not bank details. right? And over here, I want to have a glance at the modified table. So I'll type in bank holidays. I'll hit run. And as you see, initially this was 28th of April. I have modified this to 29th of April. Now let's say similarly, if I want to add 10 more days, I'll just put in 10 over here. Now let's see what is the result. Let me run this. So it was 29th of April, and when we add 10 more days, it becomes 9th of May. So this is how you can add or modify details over here. Now similarly, if I want to subtract, so I'll put in -3 over here. Now let me run and see, right? So it was over here 9th of May, and when I do -3, I have 5th of May over here. So this is how we can work with it. Now after this is done, I'd have to go ahead and update the end time over here. So we had the end time column, so we had to update the end time column with current European time. So again, we'll use the update command and we'll set end time is equal to UTC timestamp. So if we have to update it with European time, so we'll have to use UTC underscore timestamp. Now I'll delete all of this. Let me write in the command from the beginning. So update bank holidays set and time is equal to UTC timestamp. All of this is set, and then I'd have to have a glance at the modified table. So select star from bank holidays. Now that this is done, I'll click on run, right? So initially we had all zeros over here. Now that we've updated this, we have 648, 44. And once this is done, we've again go back to the bank details table over here, and inside the bank details table, let's say I have this product column. Now I want to display this product column with a new name. So I don't want to show this as a product column, but I want to show this as a new product column. So what I'll do is I'll just use a select command. So select product as, and I'll give in the name by which I want to have a glance at it. So select product as new product from bank details. So let me run this command. Select product as new product from bank details, and this is what we have. So actually the name of the column is product, but I'm displaying this as new product. And then after this, let's say if I want to show only the first record from the table, so we can go ahead and use the limit operator over here. So display only one record from bank details. So to do that, we'll type in select star from bank details and we'll set limit 1. Now select star from bank details because we want all of the columns but not all of the records. I'll set the limit to be equal to 1, which would give me only the first record or the top record over here. And then finally we have one last question. So I want to display the first 5 characters of geolocation of bank details table. So for that purpose, we'd have to use the substring functions. So we'll type in select substring, and this takes in 3 parameters. So the first parameter is the name of the column, and then we'd have to add the starting index and the ending index. So these are all the index values for the characters which we'd want to extract for that particular record. Now, to actually find out the substring of that particular record, we'd have to add some values over here. But as you see, there are no values. So to add values, we'll use the update command. So we'll type update and we'll set geolocation, update geolocation set. So this is not actually update geolocation. This has to be name of the table first. So I'll type in update bank details set geolocation is equal to, let's say it is New York, where I'll maybe set where product is equal to pay card. Now let me see if this change has been done. Right, so we have successfully updated this. Now similarly, I'd want to update the geolocation to, let's say, New Jersey, where product is equal to pay points. Let me change this to pay points now. And let me run this. So even this command has been executed. Now, let me see the modified table. So select star from bank details. And this is my modified table over here. Now to get only the first 5 characters, what I'll do is I'll use select substring over here, and in this I'll just give in 3 parameters. So the first parameter would be the name of the column. So the name of the column is geolocation, and after this I'll give in the first index and the last index. So I'll give in 1, 5. Select this from, and I want to select this from actually bank details, where since I want this for the first record, so I'll type product is equal to pay card. Let me change this to pay card over here. Now let me hit run, right? And these are the first 5 characters. I've got new underscore y. Now similarly, let me change this to pay points over here, and let's see what do we get. Now we get new j. Now we'll head on to the second part of the lab session. So this time we've got some more queries. So we basically are dealing with 2 data sets. So we have the cricket1.csv and the cricket2.csv. So this cricket1 is the table for all of the players who've played in test match 1, and cricket2 table is for all of the players who played in test match 2. Now let's start off by having a glance at these 2 tables first. So I have my CSV files open over here, and this is the cricket1 CSV file. I've got 4 columns: player ID, player name, runs, and popularity, right? So these are the different players who played in test match 1. Now similarly, I've got cricket2 table over here, and in this I have player ID, player name, runs, and charisma. So the difference between cricket1 and cricket2 CSV files are, in cricket1, over here we've got the popularity column, and in cricket2 we've got the charisma column. Now let me head to the notepad again over here, and let's start off with our commands. So our first command would be to find out all of the players who are present in test match 1 and test match 2. So this is not an intersect, this is basically union. So this is a union of all of the players. So basically, what is the team? What are all of the players who were present in test match 1 as well as test match 2? So for this, we'll have to use the union operator. So we'll given the command select star from cricket1 union select star from cricket2. So over here, instead of using the star operator, you can actually give the name. So we'll just put in player name, and that would give in the list of all of the players who have played in either the first test match or the second test match. So let me go to MySQL Workbench over here. Now before we go ahead and apply all of these commands, our task could be to import these 2 tables into MySQL Workbench. So I'll be importing these 2 tables into the world database over here. So I would have to right click on the world database, and over here I have this option of table data import wizard. And over here I would have select the browse option. And inside this, I will give in the name of the file which I'd want to import. So I have the cricket1.csv file. I'll import this. And once I select this, I'd have to click on next. And as you see, if we don't have the table, if this is not an existing table, then MySQL Workbench will automatically create a table called as cricket1 over here. And as you see, we would have all of these columns in cricket1, and we also have the field type. So player ID is of text, player name text, runs and popularity are of integer type. I'll click on next, and when I finally click on next, this will import the data and also prepare the file. So the data has been successfully imported. Now I'll just click on finish. Now inside the tables, if I refresh this, I would have the cricket1 table ready. Similarly, let me go ahead and import the cricket2 table. So I have the table data import wizard. Now I'll click on browse, And this time I'll be importing the cricket2.csv file. So I have selected this. All I have to do is click on next. And again, we would have this table ready over here. So player ID, player name are of text type, runs and charisma are of integer type. Next, let it import. And once the import is done, again, click on next, click on finish. Now let me refresh it over here. Now we also have the cricket2 table ready. Now just to be sure, let me also show you these two tables inside MySQL Workbench. So first I'll type in select star from cricket1. Right, so this is our cricket1 table. Similarly, when I put in select star from cricket2, that'll give me my second table. So our first query was to find out all of the list of players who were either present in test match 1 or test match 2. So for that purpose, I will type in select and I would want the names of the players. So I'll type in player name from, and the first table would be cricket1. So I'll type in cricket_1, and after this I'll have to give in the union operator. Now similarly, since I want either the players who have played in test match 1 or test match 2, after this I'll give in again player name. So this would be player name from, and name of the table is cricket2. So this would give us the entire list of players who have either played in test match 1 or test match 2. And then we have our second query over here. So we'll have to write a SQL query to find out players from test match 1 having popularity higher than the average popularity. And this would be the syntax for that. So we would have to find out players whose popularity is higher than average popularity. So for that purpose, first of all, I'll select the player name because I'd want to know which player or whoever player has higher popularity. So player name, and then I would also need the popularity from cricket1 where popularity is greater than, and over here now this greater than has to be for a subquery, and inside the subquery I'm giving select average of popularity from cricket1. So till now we have not worked with any subqueries, so this might be a bit difficult for you to process. So let's understand this from the right side. So we'll start off by getting the average popularity from cricket1 table. So when I type in select average of popularity from cricket1, this would give me the average value of popularity for all of the cricketers. Now I would want player name and popularity for all of those players whose popularity is greater than this value. So first we'll find out this value, and then we'll find out all of those players whose popularity is greater than this value. So let me go to MySQL Workbench and implement this. Let me remove all of this. So I'd have to start off by finding out the average popularity. So for that purpose, I'll type in select average of, and inside this I'd have to type in popularity from cricket1. So we see that we have an error over here. So the name of the table is wrong. Right, so we see that the average popularity of a cricketer is 9.8333. Now I'd want all of the players whose average popularity is greater than this. So I'll put this inside braces over here, and let me give in my main command over here. So which will be select, what do I want? I would want the player name, and I would also need the popularity. So let me also type in popularity over here. So select player name and popularity from cricket1 where the popularity has to be greater than 9.8333. Now let me hit execute, and this is our result. So as we see, all of these players, their popularity is greater than 9.833. And it seems that Dhoni has the highest popularity of 15 over here. After that, we'll have to find out the player ID and player name that are common in test match 1 and test match 2. So guys, understand the difference between this and this over here. So over here, we wanted to find out the entire team, that is the list of players who either played in test match 1 or test match 2. Here, we'd want to find out all of those players who have played in test match 1 and as well as test match 2. So this would mean that this is the intersection over here, right? So these are players who are part of both of the test matches. So now since we want player ID and player name, we'll start off by typing out select player ID and player name from cricket 1, which is the first table, where cricket 1 dot player ID in, again we'll give in a subquery over here, select player ID from cricket 2. Now over here this means that we are selecting only those player IDs from table 1 where the player ID is also present in cricket 2, right? So when you use the in operator over here, this means that this player ID is also present in the player ID of table 2. Now if this seems complicated, let's again go to SQL Workbench and let's implement this command over here. So I would want the player ID and the player name. So I'll type in select. So my first column would be the player ID. Let me just give in the player ID over here. And after player ID, I would also need the player name. Select player ID, player name. This would be from the table cricket 1. Where the cricket 1 dot player 1 ID, this would mean that basically whichever player ID is also present in the second table. So I will type in cricket 1 dot player ID and then I'll type in and inside this I'd have to give in the subquery. So let me write this properly over here. This is select and the subquery would be select of player ID from, and then I'd have to give in the name of the second table, which is cricket 2. Now let me hit execute. So these are all of the players. So we've got 1, 2, 3, 4, 5, 6, 7 players who were part of the first test match as well as the second test match over here. And then going ahead, we'd have to retrieve the player ID, runs and player name from cricket 1 and cricket 2 and display the player ID of players where the runs are more than the average runs. This would mean that I would want all of those players whose score is greater than the average score with respect to both the test match 1 as well as the test match 2. So this is the command for that. Since I want player ID, runs and player name, I'll select all of these from cricket 1 where cricket 1 dot runs is greater than average of runs from cricket 2. Now you must be thinking, why have I given only table 2 over here and not table 1? This is because if we just select those players whose score is greater than the average ID of whichever test match is higher. So over here, it seems that the average score of all of the players in test match 2 is higher. So that is why I'm comparing with test match 2. So this will give me all of those players whose scores are greater than the average scores with both the test matches. Now let me show you by finding out the average scores in both the test matches. So I'll type in select average of runs from, I would have to find out from the first table. So the average score from test match 1 is 39.33. Similarly, if I want to find out the average score from test match 2, it is 49.45. So that is why we are finding out all of those players whose score is greater than the average score in test match 2. Now it's time to write the command for that. So I would need the player ID. So I'll type in select of player ID. I would need also the player name. So I'll type in select player name and I'd also need runs. Select player ID, player name and runs from, and I would have to type out after this from cricket 1 where cricket 1 dot runs is greater than select of average of runs from, I'd have to give in cricket 2. Now if you guys still don't understand the concept over here, I'll repeat this. So instead of finding out all of those players whose score is greater than test match 1 and test match 2, what I'll do is I'll just find out all of those players whose score is greater than the higher average of both of those matches. And as we have already seen over here, the average score in test match 1 was 39 and the average score in test match 2 was 49. So that is why we are just taking out all of those players whose score was greater than the average score from the test match. Now let me hit run, and it seems that we've got only 3 players, Virat, Yadav and Rayudu, whose scores were greater than the average scores in both of the test matches. Going ahead, we'd have to write a query to extract the player ID, runs and player name from Cricket 1 where the runs are greater than 50. So this is a very simple query. All I have to do is use the select keyword and I'm extracting player ID, runs and player name from this table where runs are greater than 50. So let me type in select. I would want player ID, I would want the player name as well, and I would want the runs from Cricket 1, and I would want all of these details where this is actually greater than 50. So where runs are greater than 50. So only Yadav and Rayudu have their scores greater than 50 over here. And after this, I'd have to write a query to extract all the columns from Cricket 1 where player name starts with Y and ends with V. So for this, we have the like operator. So we'll type in select star from Cricket 1 where player name like Y%V. This would mean that we will extract all of those records where the name of the player starts with Y, has some set of characters are followed by Y, and then it ends with V. Now, when you're given this percentage symbol between two characters, this would mean that this would either mean either a single character or multiple characters. So let's go to here and let's perform this command over here. So all I'd want is select, and then I would want all of those players. So select star from, let me type in Cricket 1 where player name like Y%V. Right, so Yadav is the only player whose name starts with a Y and ends with V. Similarly, if I wanted to find out all of the players whose name starts with a Y, then inside these single quotes over here, I'll just give in a Y and then I'll follow it up with a percentage symbol. So as you see, again, we only have Yadav over here. Now, similarly, let's say from table 2, if I wanted all of those players whose name starts with a Y, so I'll type in Cricket 2 and we've got Yuvraj, Yadav and Yusuf, whose name starts with a Y. And then going ahead, we've got the next question over here. So we'd have to write a query to extract all of the columns from Cricket 1 where player name does not end with T. So instead of like, we'll just use not like over here, and after not like, we'll put in percentage T. This would mean that this ends with a T. So percentage T, this would mean you could either have one character or multiple characters, and after that it just ends with a T over here. So before we find out all of those players whose name does not end with a T, let's just find out all of those players whose name ends with a T. So select star from Cricket 1 where name like, I'll give in %, I'll give in T over here. So seems like we have an error over here. So this is actually player name. Now let me hit execute. So Virat and Rohit are the players whose name ends with a T. Now let me put in not like over here and let's see the result. So as you see in this result, we will not have Virat and Rohit because their name ends with a T. So going ahead, we'll work with the new dataset CSV file called as newcricket.csv, and this is our file over here. So this is basically a combination of the Cricket 1 file and the Cricket 2 file. Now in this, as you see, so these are the 4 columns from Cricket 1 and these are the 4 columns from Cricket 2. And wherever the values weren't present, we've just added null over here. So let me go ahead and also load this file in MySQL Workbench. So here I will perform the same command. I'll right click this. I'd have to click on this. Now I'll click on browse, and the name of the file is newcricket.csv. Open. Next. And since this table is not present, we'd have to create a new table over here, and these are all of the columns which would be created inside this. So again, next. Wait for a while and just wait for this to be done. So as you see, we have successfully created this table. Let me refresh this over here. Let me bring it down. As you see, we have this new cricket table over here. Now let me show you what is present in this table. So I'll type in select star from new table. This is actually new cricket, not new table. So I'll type in new cricket. And this is our result over here. Now from this table, I'd have to extract the player ID and player name of all the players where charisma value is null. So I'll just type in select player ID, player name from new cricket where charisma is null. So it's a very simple command over here. Let me again go to MySQL Workbench and let me perform these commands. So I'll type in select player ID, player name from new cricket where I'll type in charisma is null, and I'll hit enter. Let's see the result. So we see that these are the two columns, player ID and player name, where the charisma value is actually null. And then going ahead, we'd have to separate out all the player ID into single numeric IDs. So we had seen in player IDs, we had something known as PL1, PL2, PL3, PL4 and so on. So we'd have to take all of those and just make them. So if it is PL1, I'd have to make it 1. If it is PL2, I'd have to make it 2. If it is PL3, I'd have to make it 3 and so on. So for this, we'll use the substring query and we'll type in select player ID and substr. And in this takes in two parameters. First is the name of the column, and then over here, this we can either give in the starting index and in the index or just one. So this would mean that from this entire string, I would want just that character which is present at index number 3. So as you see, this is our entire string. From this entire string, if I take only this value which is present at index number 3, I will get the numbers. So I'll type in select player ID and substring of this would be player ID and 3 from new cricket. Let's see what do we get. So as you see, from this entire table, I have taken these two. So these were the original values of player IDs, and I have extracted only the final character which is present at index number 3. And then we have our final query over here. So we'd have to write a query to extract player ID, player name and charisma where charisma is greater than 25. So select player ID, player name and charisma, and again after that you will just give in the condition where charisma is greater than 25. So let me just bring it down over here. Let me remove this. Select. First I'd have to select player ID, then I'd have to select the player name, and then I would need the charisma where I would need this from a table. So I'll type in from, and the name of the table over here is new cricket. I'll give in the where clause where the charisma is greater than 50. So it's only Virat and Dhoni whose charisma is greater than 50. Now we'll work with a new data set. So this is our churn1.csv. So as usual, we'd have to go ahead and load this data set first, but this is a really huge file. So I've already done that for you guys. Now let me show you what is there over here. So we've got all of these columns. So this table basically tells us whether the customer would churn or not. So this is a telecom data set, and we've got all of these details: the customer ID, gender, whether the person has a partner, whether the person has any dependents on him, the tenure for which the customer has been using the network, and we've got the technical help, online movies, and so on. And similarly, we've got the payment method over here, the monthly charges, the total amount, churn, and so on. So these are the different factors which are present in this table. Now, our first task would be to write a query to count the frequency of the values in the agreement column from the table churn 1. Now, let me show you the agreement column over here. Let's just find out where the agreement column is actually from this. So we've got a lot of columns over here. Now, this is the agreement column. So these are the different levels over here. So we've got 1 year, month to month, 2 year, and so on. So we'd want to find out the number of times 1 year occurs, number of times month to month occurs, and the number of times 2 years occurs. Or in other words, we'd want to find out the number of subscribers whose agreement is 1 year, similarly number of subscribers whose agreement is month to month, and number of subscribers whose agreement is 2 years. So let's go to MySQL Workbench and work with this. So I would have to type out select, and then I'll type in agreement because that is what we want, and I'd want the count of agreement. So I'll type in count of agreement, and I would want this count with respect to the group. So from, I'll give in the name of the table, which is churn 1, and I'd have to group it with respect to agreement again. Now let me execute this and let me show you the result. So this is what we get. So you see that there are 195 entries of 1 year, 342 entries of month to month, and 262 entries of 2 years. So what I've basically done is I've grouped my data with respect to the agreement column, and in the agreement column I've got 3 levels. Now for these 3 levels I'd want to find out the count, and that is what I've done over here. Then I'd have to go ahead and change the name of the table from churn 1 to churn details. So to rename a table, I'd have to use the rename table command. So I'll type in rename table and then given the name of the table, which is churn 1. After that, I'll type 2 and then given the new table name. So I'm changing the table name from churn 1 to churn details. Let me delete this. I'd have to type rename table and then name of the table, which is churn 1. And this would be changed to churn details. So we have successfully implemented this. Now let's see what would happen if I try to read data from churn 1. So I'll type in select star from churn 1. And as you see, we get an error because churn 1 doesn't exist. Now instead of this, if I put in churn details, right, now this table exists because we have changed the name of the table from churn 1 to churn details. And then we'd have to go ahead and add a query to create a new column named as new amount, which is basically the sum of total amount and monthly charges. So over here we've got the total amount and monthly charges. So wherever these are there, so I'd have to add these two values and make it into a new column called as new amount. So for that purpose, first of all, we'd have to start off by using the alter table command. So we'll type in alter table and we'll add a new column and we'll name that column as new amount. So let's go ahead and do that. So I'd have to start off by altering the table. I'll type in alter table and I'd have to alter the table whose name is churn details. And what alteration do I actually have to do? I'd have to add a new column. So I'll type in add column and the name of the new column would be new amount. And this would be of type float. Now let me run this. Right, now let me see what changes have been done to this table. Select star from churn details. Now let me go to the end of this table. So as you see, we have added a new column to this and we also have to add values now. So the values are basically this plus this. So when I add these two, I would get something which is close to 253 over here. Right, now let's see how to do that. So for that purpose, we'll have to update the table. So we'll type in update churn details set new amount is equal to total amount plus monthly service charges. So I'll just use the update command. I'll type in update and then I'd have to give in the name of the table, which is churn details. So let me type in churn details over here, and after that I'd have to use the set keyword and give in the name of the column which I'd have to update. So I'd want to update the new amount column, and this is basically the total amount plus the monthly service charges. So this plus this would give me the values into new amount. Now this would be monthly service charges. Let me hit execute. Now let me have a glance at the table. So select star from, this would be churn details actually. So let me just type in churn details, and over here let me go to the end of this table again, and as you see we have added these two and we have found the values for all of the records over here. So 233 plus 20 would give you 254. Similarly 3579 plus 53 would give you a value something like this. So we have updated that as well. Now we'd have to go ahead and rename the column new amount to just amount. And if we have to make some changes with respect to a column, we'll have to use the alter table command. So we'll type in alter table, given the name of the table, which is churn details over here, and we'll use change. So basically I am changing the name of this column from name amount to amount, and the data type is obviously float. So there is no change in that. Now I'll use the alter table command. So I'll type in alter table, and I'd have to give in the name of the table, which is churn details. So alter table churn details, and since I have to change the name of the column, I'll type in change. So old name of the column was new amount, and I'd want to change it to just amount, and the data type is float. Now again, let me go ahead and have a glance at the modified data set. So it will be select star from churn details, and when I run this, I see that this column, the name of which was earlier new amount, it has been changed to just amount. And then going ahead, I'd have to also drop this column. So to drop a column from a table, I'd have to just use this alter table churn details drop column amount. So let me go ahead and drop this column as well. So again, I'd have to use the alter command. So alter table churn details, and I'd have to use the drop command. So what do I have to drop? I'd have to drop the column called as amount, and then just put in a semicolon and then hit execute. Now let me see if this column has been removed or not. So select star from churn details. Let me go to the end of this, and as you see, the column which we had created has been dropped as well. Now after dropping the column, we'll have to write a query to extract customer ID, internet connection, and gender from the table churn details, where the value of the column internet connection has I in it. Now let me go to the internet connection column. Let me see what exactly do we have to do over here. So this is the internet connection. So as you see, the second character has to be I. That means that we have fiber optic value over here. This basically means we'll have to extract all of the records where the internet connection is equal to fiber optic. So this is what this query is asking us to do. So where the value of the column internet connection has I at the second position over here. So as you see, we have I at the second position. We'll type in select customer ID, internet connection, and gender from churn details, where internet connection like underscore I %. This means that we would have some character at the first position. At the second position, we'll have I followed by any number of characters. So select, let me start off by giving all of the names of the columns which I'd want to extract. I'd want the customer ID, and then I'd want the internet connection as well. Then I'd want gender. So these three I'd want from the churn details table, and the condition is where the internet connection like. So here the first character could be anything. The second character needs to be I, followed by either one or more characters. Now we have an error over here. We don't have a customer ID, so this is not an underscore over here. So now let me just hit enter. Right. So as you see, we have extracted these three, and in the records we only have fiber optic. Now there are a lot of internet connections. From all of those internet connections, we have extracted only those records where the internet connection is equal to fiber optic. So similar to that command, we'd have to execute another one where we'd have to extract all of the records where tenure is 6x, where x is any number. This means that the tenure has to be in the 60s. It could be either starting from 60 going on till 69. So 60, 61, 62, 63 till 69. It could be any of these values. So we'll type select star from the table name churn details where tenure like 6 underscore. So select and then star from name of the table would be churn details. Let me write in the name of the table properly, where tenure like 6 underscore. So this has to be in single quotes actually. I'll type in 6 underscore over here. Now let me hit execute and let's see the result. So in this tenure column, if you see that all of the values, they are in their 60s, right? So 67, 63, 60, 63 and so on.